Hello and welcome to Data and AI Summit 2021. I'm Ali Ghodsi, co-founder and CEO of Databricks, and I'm coming live from the lakehouse. And if you don't know what that means, it'll hopefully become very clear in the next couple of days. Thank you for taking time to join us. We have a fantastic event planned for you this week. In our 9th year, our 2nd year as a virtual event, Data and AI Summit has become a truly global event for the entire data community. We have over 100,000 attendees from every industry, from over 150 countries in every corner of the world. Developers, data engineers, scientists, analysts, architects, students, and a broad range of technology leaders. A true community event where we learn from each other and share the latest innovations and move our industry forward. For those of you who have attended our event in the previous years, you've probably noticed that we changed the name of the summit. It went from Spark and AI Summit to Data AI Summit. And I want to quickly explain why we did that. We always want this to be the premier event for the entire data community, which means we need to evolve as the industry and the community evolves. Today, Spark has become the standard for large-scale data processing, and along the way, it has rapidly accelerated the whole industry. New open source technologies like Delta Lake, MLflow, Qualys, Redash, PyTorch, and TensorFlow mean that new use cases and broader data community. And this new conference name and contents is meant to reflect these shifts. As you'll see, we will continue to have deep and dedicated focus on Spark through training, content, and speakers, but we've also added a lot more to cover the full technical spectrum, from data all the way to AI. In our morning and afternoon keynote sessions, you'll hear from a dozen of the top innovators and thought leaders in the industry. This includes Matej Zaharia, the original creator of Apache Spark and MLflow, Reynold Shin, Databricks chief architect and top contributor to the Apache Spark project, Shafi Goldwasser, who got the computer science equivalent of Nobel Prize, the Turing Award, Bill Inmon, who is regarded by many as the father of the data warehouse, Matt Garman from AWS, who led the creation and launch of the legendary Amazon EC2 service, DJ Patil, the former chief data scientist of all of the United States, and a number of data team leaders in organizations like Atlassian, McDonald's, Estee Lauder, and JP Morgan. We also hear inspiring talks from special guests like Malala Yousafzai, the world's youngest Nobel Laureate, Bill Nye, the science guy, the CEO of Planetary Society, best-selling author Michael Lewis and Charity Dean, as well as the engineering leaders behind NASA's Mars 2020 mission. They all have amazing stories to share, and we hopefully challenge us to think and see more broadly about the role that data and AI can play in the world. But in addition to hearing from all of these speakers, we also want to hear from you. Please get social and participate in the Data and AI Summit conversations. Share your thoughts and perspectives, and help us make this virtual experience as interactive and as engaging as possible. Be sure to use the hashtag Data and AI Summit. I also want to take a moment to thank our sponsors. This event would not be possible without the support and partnership of these organizations. So please join me in thanking them for making Data and AI Summit happen. You can visit all of our sponsors in the Dev Hub and the Expo in the top nav of your Summit interface. From your dashboard, which you can see here, you can also access your personalized agenda, featured sessions that are playing at any given time, and all the different ways to engage with each other. And if you're a Databricks customer, be sure to visit the Databricks experience for specific content and activities that might be of interest to you. We've also created an easy way for you to support the nonprofit organizations that we're sponsoring at this year's summit. As a data community, we have a unique opportunity to help solve some of the world's toughest problems. And giving back is another important way to participate in that mission. This year, we are proud to partner with 3 organizations that are driving impact and change in different ways. The first is care.org. CARE's mission is to work around the globe to save lives, defeat poverty, and achieve social justice. Today, as COVID-19 continues to have a devastating impact on India, CARE is one of the leading organizations in the region focused on providing essential services and equipment to those who need it the most. The second organization is Technovation, whose mission is to empower the world's underrepresented young people through engineering and technology. Nobody understands the potential and impact of computer science and AI better than we do. Technovation is squarely focused on helping young people, especially girls, understand and participate in these fields, reducing the talent shortage and gender imbalance in our industry, and building a new generation of technology leaders. A third organization is the Natural Resources Defense Council, which is dedicated to safeguarding our natural systems. One of the main areas that NRDC focuses on is climate change, driving programs and legislation that help reduce our dependence on fossil fuels and expand our use of clean and sustainable energy. You can learn more about each of these organizations and make a contribution by clicking on the Give Back box in your dashboard. But at Summit, we want your contributions to go twice as far, which is why I'm proud to share that Databricks will match all donations up to $50,000. So together, we have the opportunity to contribute up to $100,000 to these important causes. Let's work together and make it happen. Let's all contribute and participate in solving some of the world's toughest problems, because that's fundamentally what our community is all about. If there is one thing that we all have in common, it's that we believe in the impact that data and AI can have and will have on the world. It is still very early days, but today, data and AI is transforming every major industry. In healthcare, it is redefining patient experience, diagnosing diseases before they happen, and accelerating drug discoveries. In financial services, it is preventing fraud and regulating markets. In manufacturing, it is streamlining supply chain and driving predictive maintenance. In media and entertainment, it is connecting people to experiences and keeping us engaged like never before. In retail, it is personalizing the customer experience and responding to market dynamics in real time. The list of these use cases is massive, and this is just a short list of those. This is truly just the beginning, and we can do much more together. But the other thing that we have in common is a conviction of how we can get there. A shared belief that the future is open. The vast amount of innovation in the data world comes from open source. From the smallest startups to the world's largest enterprises, open source adoption is happening faster than ever. The collective ability of the community to knock down old barriers, solve new problems, and bring different personas closer together is rapidly changing the data landscape. This is why we made the theme for this year's event, "The Future is Open." And we thought it would be appropriate, as the open source communities represented in this audience today are directly driving this advancement. Collectively, these projects see over 30 million downloads a month. Apache Spark has long been the standard in data processing. MLflow is now the most widely used open source project in ML platform. Delta Lake has ushered a new standard in the data architecture of the lakehouse. And these are just a small sampling of open data projects that this community is working on. More than ever, the right people within an organization are able to access and work with the right data and get value from it at any given time. And the biggest opportunity for value from data today comes from AI and artificial intelligence. In 2011, Mark Andreessen said, "Software is eating the world." Today, it's evident that AI is going to eat all of software. For example, last year, this horrible pandemic hit, but we started working on these vaccines, and actually behind the scenes, the vaccines, the healthcare companies leveraged Databricks behind the scenes to actually develop these drugs and the vaccines. But it's not just the pandemic. It's also traditional industries, like ABN AMRO, which is a bank, leverages data and AI with Databricks to actually move into the future and be much more efficient in how it does banking. Also, logistics and transportation company like J.B. Hunt leverages data and AI. They've built a lakehouse and can now do much better logistics using AI. However, despite the allure of AI, most enterprises are still struggling to succeed with it. AI remains a 1% problem, with only a few web-scale organizations like Google, Amazon, Uber, Netflix, and Facebook that are able to achieve AI across the whole organization. Every BU uses AI at these companies. A big reason for this is that they have massive repositories of data and armies of data engineers and data scientists to throw at the problem, and they've been at it for 2 decades. The other 99%, they're still struggling. The hardest part of AI is the data piece, and data infrastructure is too complex and expensive to manage effectively for advanced use cases. Teams aren't well connected to collaborate. The challenge starts in the way that the data infrastructure itself is built from the ground up. The vast majority of data is flowing into a data lake today. Companies do a lot of data prep and validation so that they can serve data science and machine learning on top of these data lakes. At the same time, a huge amount of data is ETL'd to many different downstream data warehouses to do business intelligence and other use cases. We have to do that because the BI workloads are often too slow to run against the data lake directly. Depending on the workload, data also needs to be moved out of the data warehouse back to the data lake if it's been updated in the data warehouse. And increasingly, machine learning workloads are also reading and writing to the data warehouses simultaneously. The root of the problem is the inherent differences between the data lakes and the data warehouses. On the one hand, we have data lakes that do a great job of supporting machine learning and AI. They support all kinds of varieties of data, they have open formats, and there's a big ecosystem on top of them. But they have poor support for business intelligence, and they suffered complex data quality problems. On the other hand, we have data warehouses that are great for business intelligence applications, but they have limited support for machine learning workloads, and they are proprietary systems with only a SQL interface. Unifying these systems can be transformational in how we think about data. This is why we're such big believers in the lakehouse to provide one platform to unify all your data, analytics, and AI to allow members of your data team to collaborate together. By definition, a lakehouse is based on open standards and open source. Because without being open, it is impossible to create unification across all these different data types, all these tools and workloads. And the communities for the best open source projects to enable the lakehouse are in the audience today across Apache Spark, Delta Lake, MLflow, and Redash. The collective result has been really transformational for many organizations. In fact, more organizations than ever are adopting the lakehouse architecture to achieve their data goals. We're seeing enterprises like Shell, Ford, Condé Nast, McDonald's, and Halliburton standing up lakehouses, as well as digital natives like Samsara, Grab, Wildlife Studios, Grammarly, and Scribd. But I think one of those other important signals that the lakehouse is a future is how we're viewed by luminaries in the data space. For example, I recently had a chance to chat with Bill Inmon, the father of the data warehouse, to discuss his opinions on the lakehouse architecture. Bill, super excited to be here with you. We started talking a while back, and obviously we're big believers in this lakehouse concept. And we started working with you around this, and you started writing about this and evolving your thinking. You were cranking out material around this data lakehouse. You've seen this industry over many decades, and you've seen it evolve and go through different transitions. I'd love for you to walk us through the sort of evolution from, started with data warehouses to data lakes to the lakehouse. And you've also generously shared with us some images from your upcoming book. So maybe we can look at those and you can walk us through this evolution.
In the beginning were applications, and people started building applications. And then they discovered that they had data everywhere. And it wasn't a matter of, can I find data, because data was everywhere. That became a question of, can I find the right data? And that's when people discovered that they needed integrity of data. And that's where the data warehouse came in. The data warehouse, the discipline required to build a data warehouse and to vet the data was the impetus for building a data warehouse and answering the question, what is the right data without having to go throughout the organization? And then data warehouse came along. After data warehouse came along, we discovered data marts. And then we discovered quite a few other things along the line. And then the world began to discover other forms of data. We began to look at analog data. We began to look at textual data, and we found out that there is a wealth of information that hasn't ever been looked at before. I think it's kind of interesting to note that if all you look at is classical structured transaction-based data, you're probably only looking at 5 to 10% of the data in the corporation. And there's nothing wrong with that, because you need that data, but you're not looking at the full picture of what's going on in the corporation. And every now and then I'll pick up a book on data management and data architecture, and all the person talks about is structured data. And I thought, this is not right, because they're only looking at a fraction of what is in the corporation. In order to look at what's in the corporation, you've got to look at structured, textual, other unstructured. Other unstructured would include IoT data, would include analog data, would include a wide variety of data. That's the picture of the real data in the corporation. And so that's what we're faced with today. Now, in truth, the world is facing an avalanche of data coming from all over. And the challenge is, number one, organizing the data so that you can understand what's there. Number one, Number two, merging the data together so that you can find out information that goes across more than one of these environments. That's a second challenge. Number three, organizing the stuff so that you can find anything, because there's so much data that's out there. Trying to organize the information to where it can be found is the challenge. And so if you take the data and just put it into a data lake, that's a good first step. But it's only the first step. That after you've created the data lake, you then got to say, okay, I need to have another layer of analytical information for it, because such things as lineage of data. I mean, again, it's kind of interesting to know what a value of data is, but until you can understand where did that data come from, when did it come into the system, what's been done to it, what hasn't been done to it, all of those informations are relevant to understanding how to do analytical processing in an effective fashion. So if I were to look at this diagram that's in front of us now and say, where is the industry? The industry is at the point of building and or going to build a data lake. And then the next step is them discovering that they need an analytical infrastructure in order to make that data lake comprehensible and usable. And this is where machine learning would come in, and a lot of other things. So that's where I think we are today. And so here we see that analytical infrastructure that needs to be added to the data lake in order to turn it into usable data. This unlocks the data for the end user so that not only can the data scientist use the data, but the end user can use the data as well. And once we do that, we've opened up the door to lots of other analytical tools. Certainly machine learning, certainly data science and statistical processing, but all kinds of other people can now start to go in and find and use the data.
And this is, these are your images from your book, and your images, they go from top to bottom. So up at the top is where the data comes in, I believe.
Yep.
And
Yep.
At the bottom is where you're actually the use cases where you're getting value out of that data.
That's correct.
That's fascinating. Many of us are fans of your book, Building the Data Warehouse. And we actually taught it. We were taught it, and then we've been teaching it at universities, and we're big fans. Is there, are we going to see more books from you?
Yeah. I've done in my life 60 books now. The 61st book is one on the data lakehouse, which I'm working on right now. And in many ways, the data lakehouse has a lot of, not all of, but a lot of the propositions that was facing data warehouse 25 or 30 years ago. So I'm working now on the definition of what is a data lakehouse and how do you go about building it and what are some of the characteristics.
Yeah, and in the lakehouse, is that a first-class citizen, the data science?
It's kind of interesting. It's my observation, and I could be wrong about this, but it's my observation that when the first notions of the data lakehouse came about, that it was primarily for the data scientist. But there is another whole community of plain old end users that need to look at that data as well. So in order to accommodate, and it's really kind of interesting, the data scientist looks at one kind of data and the end user looks at another kind of data. It's the same data, but it's looked at in different ways. And so I think in terms of the maturity of the data lakehouse, we need to start to accommodate the end user. I think the data scientist, I think the data lakehouse was originally built with the data scientist in mind.
Yeah, that makes a lot of sense. And then now expanding it to also include the traditional BI workloads and end users who might want to see simpler dashboards or have places where they can actually understand the data more, in a simpler way. Is that
Absolutely, that's true. And actually, the data scientist and the end user are probably looking for different things. I mean, they might be looking for the same thing, but in general, the data scientist is looking for patterns, trends, and things that haven't been seen before, and the end user is typically looking for things like KPIs, key performance indicators, and things like that. So they're essentially using the same data, but they're looking at very different things in that data.
That's fascinating. And last, decade or so, you've been working on textual ETL yourself.
That's correct. We've been taking the technology of the problem of looking at text and asking ourselves the question, how do we turn this text into actionable information? Because there's actually a tremendous amount of business value that's buried in text that isn't being looked at today.
And these are text records that might not even have a lot of structure to them, right? This is not tabular text that you get that's adheres to a particular schema when it comes in.
If you're waiting to have structure in text, you're going to be waiting a long time. 99% of the text that's out there in the world has no structure. I mean, it's like our conversation. There's nobody sitting there telling you what to say. There's nobody telling me what to say. We're just having a conversation. And so in terms of structure, I don't know, we're certainly friendly with each other, but there's not really any structure to what we're talking about, nor is there for emails, for what's on the internet. I mean, text and structure just really, as far as I can tell, doesn't exist in text, or at least if it does, it not very much.
How do you do that with your textual ETL? How do you understand the context?
I can tell you, having been doing this the last 10 years of my life, that managing text is 10% of the battle, and managing and understanding context is 90% of the battle. It really is difficult. Different text has different requirements. Some text can be handled one way, other text can be handled a completely different fashion. And so the last time I looked at our technology, we have about 67 different algorithms in our technology, and our technology goes in and selects the appropriate algorithm for the given piece of text at a time.
And you said you have 67 algorithms or so that understand the context. How are these built? There must be a lot of variety.
Let me give you a flavor of just some of the algorithms. One of them is something called homographic resolution. And suppose you were a doctor and reading doctor's notes, and you saw the term HA. Now, what does the term HA mean? Well, if a cardiologist wrote HA, it would mean heart attack. If a general practitioner wrote HA, it would mean headache. If an endocrinologist had written HA, it would mean hepatitis A. So the interpretation of what HA means depends entirely on who wrote it. And that's one of our 67 algorithms that we have orchestrating how do we determine context.
Got it. So you're really using these advanced statistical techniques and these sort of to understand the context from these 60 or so algorithms, and they sort of search over the data multiple passes. And is that done on a sort of lakehouse pattern?
What we do is we read the raw text and then put it into a form that goes into the lakehouse. Once it's in the lakehouse, it can then be analyzed and mixed and merged with other kinds of data.
Speaking of languages, when the processing that your textual ETL does in the lakehouse, do you have a variety of also programming languages that you're actually using to access them, or what's this written in actually? I'm curious, your technology.
The underlying technology that we have is Microsoft VB.NET.
So Bill, I'm curious on your take of ELT versus ETL.
Certainly. That's actually a knotty question, because there are advantages and disadvantages however you do it. I've always been a fan of ETL because of the fact that ETL forces you to transform data before you put it into a form where you can work with it. But some organizations want to simply take the data, put it into a database, then do the transformation. Now, when it comes to text, text is a different beast altogether, because I'm not a believer that you can do ELT with text. I'll tell you what, if you can do it, I don't know how. And we do this every day. And so I think for text, you don't have any choice but to do ETL. Other technologies, you do have a choice, and there are some reasons for doing ELT, and I understand those. But again, I'm a fan of ETL because ETL forces the organization to do the transformation. And I've seen too many cases where the organization says, oh, we'll just put the data in and transform it later. And guess what? 6 months later, that data has never been touched.
The way we see it is when there's more structure to your data, you can do ELT because you can load it in and you can use SQL. Yeah. With SQL, you can do a lot of the transformations actually once it's loaded in. But as you pointed out, for all these complex data types, the text and the audio and video and all these other, the data science workloads, it's just very hard to express that with SQL.
Yeah, with images, for example, I don't believe you can do ELT with images. I mean, maybe you can, but I don't know how it's done.
Yeah, well, a lot of these machine learning frameworks that actually analyze the images, they directly access the files and do ETL.
Yep. That makes sense to me.
So, so switching gears, end user is really important. There was this concept of data lakes for a long while.
Yep.
Persisted. Would you say the data lakes did a good job of addressing those end users?
No, the data lake was not thought out from an architectural standpoint. From a technical standpoint, I think the data lake, I mean, that was fine, nothing wrong with it. But architecturally, there were many things missing from the data lake, and because they were missing, it made the data lake not useless, but it made it very difficult to get information out of.
I mean, you've worked in this space a long time. Would you say many data lakes turned into data swamps?
Most of them do. Every now and then you see one that doesn't, but most of them do.
And the lakehouse, how does it? So it takes that data lake, but now also adapts it to end users, helps you with the structure that you need, so that you can actually make sense out of that data, not just turn it into data swamp.
That's correct. What I can say, yes, that is correct. That if you take your data lake and turn it into a lake house, you can actually now start to get your money's worth out of it. If you don't turn it into a lake house, it turns into a swamp.
How important is open source, open aspects of these architectures today? I mean, that didn't exist when you came up with the concept of data warehousing, many decades ago. But today,
many decades ago, Oracle and IBM and Microsoft had secrets. I mean, they tried to keep everybody from openness, and I think the world that we live in today is, first off, is a different world, and I think it's a positive thing that it's different. And the data warehouse would have accelerated way back when had we had openness back in that day and age. And I'm glad that we have it in this today.
Yeah. So is it a good summary to say the lakehouse gets the data science focus from the data lakes, but it also gets the application and the BI focus from the warehouse and blends them for all these variety of data sets that you referred to earlier? Is that a good summary?
I would absolutely agree with that statement.
That's awesome. I'm going to get a little bit personal here. So when we started talking, you started writing these blog series about the lakehouse.
Yeah. Mm-hmm.
And it seems you're writing them in the middle of the night. Tell us a little bit what's going on.
I'm a writer. I've written 60 books right now, and to me, writing is a form of relaxation. For most people, writing is hard work. But at this point in my life, I would rather sit down and write a good book than I would go out and play a game of golf. And so writing to me is a form of relaxation. And I enjoy it. It's like doing a crossword puzzle. It's an intellectual challenge. I enjoy doing it, and there's nothing that I would rather do than sit down and write a good book. And I mean, God has made different people different ways, and God made me a writer, and so I write very quickly. If I were, some artists, the painters, take a long time to make a painting, and some painters paint very quickly. Well, I would be one of those painters that painted very quickly.
And we've been big fans of the Lakehouse, but you've helped us actually evolve that through your writing. And and we couldn't keep up with your writing because you keep cranking them out at very fast pace. But we at Databricks we would have whole groups of people sit there and read these and try to say, wow, actually we haven't thought about that.
Wait till you see the book, which, by the way, is now on chapter 8. So I hope to have the book finished by next week. But wait till you see the book. There's a lot of information that I think that Databricks and the world is going to find useful.
The Lakehouse. When you said when you wrote the book Building the Data Warehouse, you wanted everybody to go off and build their data warehouse.
Yep.
So you're now writing a book on the Lakehouse.
Right.
Is the intention that you want people to run off and build lakehouses?
Absolutely. I'll tell you what. It's almost a different proposition. What if people don't go and build data lakehouses? They're going to end up with this flood, this avalanche of data that they're not going to know what to do with, and that's going to be tragic because you can do so many things with the data. So it's not so much a problem of are they going to build a data warehouse. It's going to be what happens if they don't build a lake house. And because if they don't build a lake house, they're going to have this mountain of data that sits there, and nobody's going to be able to do anything with it.
In the long run, what do you think the impact of the lakehouse will be? And if you put it in perspective with the previous sort of industrial kind of impact that data warehouse has had?
Well, I believe the lakehouse is going to unlock the data that is there and going to present opportunities like we've never seen before. And that's going to be the effect of creating the lakehouse.
As Bill and I discussed, Delta Lake is a key enabler of the lakehouse because it fixes the limitations of data lakes. On their own, data lakes have several challenges. First, it's really hard to get reliable, quality data because you're bringing together a huge variety of data sets. Second, it's hard to get great performance. If you have millions of tiny files to read, lakes just aren't built to do that really quickly. Third, you're operating at the file level. You can't deal with the contents of the files, so security is all or nothing. And if you want to have sharing on subsets of the files or versions of the files, we have to make lots and lots and lots of copies, which makes governance really, really hard. Delta Lake provides the ability to build curated data lakes. So now you have reliability, performance, and governance that you expect from data warehouses directly on your data lake. You gain reliability with ACID transactions. Now you can be sure that all the operations you do on your data lake either fully succeed or they're aborted and the residue is cleaned up. You can also time travel back and forth in your data sets, which is really important for governance and compliance. And we're able to enforce really strict schemas on your data so you can avoid having the data become a data swamp. Additionally, as data flows into a Delta Lake, we build indices. These indices help us actually do really, really fast queries on the data later on so that you can match the performance of data warehousing directly on your data lake. And finally, Delta Lake provides support for fine-grained access control. That's really important because you want that in the enterprise where you want to maybe hide some data sets and you want to lock them down and make sure that you're really secure. This project has come a really long way since its inception. In fact, the 1.0 release was just certified by the community. Now, to tell us more about this milestone, I'd like to welcome Michael Armbrust, Distinguished Engineer at Databricks, to the stage. Hey, Michael.
Hey, Ollie. Thanks. It's been a long journey to get to Delta Lake 1.0. But before we start there, I'd like to take a look back at where we've been and figure out how we got here. Delta Lake was first open sourced in April of 2019. And that first version was pretty exciting. It included ACID transactions and schema management. It included streaming and batch, but we didn't stop there. We quickly added support for DML commands and for vacuuming. We added Scala and Python APIs. We added improved compaction and concurrency. We made it possible to convert Parquet tables into Delta using only SQL. We added things like describe history, which allow you to understand how your table has been evolving over time. We added support for a whole bunch of different engines like Presto and Athena. And finally, we've really been working a lot on merge and other features as we approach the 0.8 release. Today, Delta is used all over the world. We process over an exabyte of data per day. It accounts for over 75% of the data that is scanned amongst all of Databricks customers. And we have over 3,000 customers using it today in production. And that's why I'm really excited to announce Delta Lake 1.0 with a suite of new features that make it available everywhere. The first feature I want to talk about is generated columns. The problem that you're solving with generated columns is one that data engineers are very familiar with. You have a table that has a timestamp column in it, but you don't want to partition by timestamp. That would result in way too many partitions. So instead, you want to partition by date. So you could do this. You just add a column that takes that timestamp and converts it into a date. But you need to manually create that column. You need to tell all of your users that they need to manually add predicates to query both of these. Otherwise, they won't be able to take advantage of optimizations like partition pruning. And this is obviously error-prone and costly if forgotten. It can change your query runtimes dramatically. And that's why I'm really excited to announce generated columns. This allows you to specify that you want this date column or whatever column you want to be generated to be automatically added. Delta understands the functional dependencies between these two columns. So if you write a predicate against the other, it can infer the predicate that should be added against the other one. And unlike other projects where this is kind of a physical concept that is limited to only partitioning, generated columns is based on standard SQL. And so it's ready for your lakehouse. Using it is pretty simple. All you need to do is add a little bit of extra information in your DDL when you're creating your Delta table. So you can see here, I define an event date, and I just specify how to generate it. If the user specifies it, we'll confirm to make sure it's correct. And if they don't, we'll automatically fill it in with the correct value. I think this is going to be huge for performance and also ease of use for Delta. Another really exciting feature coming in Delta 1.0 is cloud independence. Now, what do I mean by that? Delta has always worked on a variety of storage systems. You could use it on Hadoop, you could use it on S3, you could use it on ADLS Gen 2. But with the advent of Delta 1.0 and the delegating log store, you can have a single cluster that reads and writes from different storage systems. This is pretty awesome because it means that you can do federated querying across your data stored in different clouds, or you can use this for cross-region consolidation, taking information from all of the different places you have it and bringing it into one place. And I think this is a pretty cool feature because we've also been expanding the set of file systems that is supported by Delta. So we recently added support for Google Cloud and also IBM Cloud. And if you don't see your favorite one on here, stay tuned towards the end where we'll tell you how to get involved. Another feature that Delta has always had was multi-table transactions. So the idea here is I have multiple clusters that are all writing to a single Delta table. And what you're going to see is the Delta ACID transaction protocol is able to mediate across all of these different clusters. So if two clusters try to update the same data at the same time, it will check to see if there's any conflicts. And if so, it'll abort one of them so they can retry later. This has worked on Hadoop, where we have transactional rename, and also on ADLS Gen 2 and Google Cloud. However, users of S3 have always been left in the dark. It turns out that S3 is missing the transactional primitives that we need to build this. And that's why I'm really excited to talk about a new initiative that's going on in open source, where a couple of different open source committers are adding the ability to use DynamoDB in the ACID transaction protocol to actually mediate between these different writers. So users from S3 can also write to a single table from multiple clusters. When Delta started, it was pretty much a Spark project. We had really good integration with Spark, so you could use the streaming and batch APIs to read and write from Delta tables. And I'm a little biased. I think Spark is pretty good, but it turns out that there's a bunch of different engines out there and a variety of reasons why you'd want to use them. And that's why another kind of key feature that we're releasing is the Delta standalone reader. So this is another implementation for the JVM that understands the Delta transaction protocol, but doesn't need a Spark cluster. It can read that transaction protocol directly. And this will make it significantly easier to build other engines on top of it. We already use this inside of the Hive connector, and there's work on a Presto connector as well. And Delta is no longer limited to the JVM. There's also a Rust implementation. And one of the nice things about having native code for reading from a Delta Lake is this makes it easy to integrate with a variety of languages. So we also have support for Python, Ruby, Go, and also direct connect from Kafka all through these Rust bindings. And I'll give some pointers later in the talk on how to find more of this. Now that we've got great Python support, it's important that it's easier for Python users to get started. There's two different packages depending on how you're going to be using Delta Lake from Python. If you want to use it along with Spark, you can pip install Delta Lake Spark, and it'll set up everything you need to run Spark jobs against your Delta Lake. If you're going to be working with smaller data, or you want to use pandas or some other libraries, you don't need Spark to access Delta from Python anymore. You can just pip install Delta Lake. And this installs the native client for Delta based on the Rust bindings. And as you can see, with just a couple of lines of code, we can get started reading our Delta tables. Also, Delta now supports Spark 3.1. It's super important with the pace of advances going on in the Spark community that Delta keeps up to date with them. And so we're really excited to announce that Spark Delta Lake 1.0 works with Spark 3.1. This means you can take advantage of improved predicate pushdown and pruning available in Spark 3.1. Another place where we did some pretty deep integrations is with SQL compliance. So there's now ANSI standard, DML and DDL for doing insert, merge, and explain. And finally, we're also integrating with the catalog APIs in Spark for doing structured streaming. So if you want to stream from Delta tables that are stored in your catalog, you can now do that without having to manually deal with the path yourself. So with the advent of all of these features, Delta is now available anywhere you can want to use it. It's available from a variety of languages, a variety of services. There's connectors for all of the popular tools for data engineers, and it's also queryable from many different databases. And as my friend Tyler said, Delta Lake 1.0 is now ready for every workload. And this journey hasn't been easy, and it's involved a bunch of contributors from the open source community. That's why I'm also excited to announce that we'll be adding a bunch of new Delta Lake committers to the project. And these are coming from a couple of different companies. I'd like to highlight in particular Scribd and Backmarket, who have been adding a whole bunch of things in Rust and Kafka Connect and SQL ingest. It's a really exciting time in the Delta community. I'd encourage you to also get involved if you haven't already. There's a bunch of different channels to get involved with Delta. You can check us out on Slack or on the YouTube channel where you can find this video and other videos. There's a pretty active user group if you want to ask questions. And if you want to get involved with the actual code, I encourage you to join us on GitHub or also join the weekly Delta Rust meetings where they're talking about how that part of the project is going to evolve. Finally, I'd like to plug a book from my good friends Denny, TD, and Vinny. This is the authoritative source on how to use Delta Lake. So check this out if you want to learn more. And with that, I'd like to thank you for your time and hand it off to the next speaker. One company that's been a big supporter of Delta Lake and the Lakehouse is Atlassian. And that's why I'm really happy to welcome Rohan Dupelia, the data platform leader at Atlassian, who's going to give us some insights in how the Lakehouse has impacted their organization. Thanks.
Thanks, Michael. It's great to be here. I'm Rohan Dupelia, and I lead the analytics platform team at Atlassian. And now I've been at Atlassian for over 6 years, and I've been fortunate enough to witness a large portion of their data journey over this time. Before I get started, I'll just share a little bit about Atlassian for those of you who aren't aware. Now, we were founded over 19 years ago in Sydney, Australia, and that's where I'm calling in from today. And we now have offices globally with over 5,000 employees. And we're serious about creating products and practices that encourage open work and collaboration for all teams. And we do this with tools such as Confluence, which is a system that helps teams create and share content, Bitbucket, which gives dev teams one place to plan with projects, collaborate on code, and test and deploy, and Jira, our flagship product, which is used for bug tracking, issue tracking, and project management. Also, just a little bit about our data landscape. So we've managed to consolidate all of our data use cases into one single data lakehouse powered by Databricks. We operate at a petabyte scale, ingesting over 25 terabytes of data per day, which comes with its own host of problems, probably worth diving into in another talk. We have around 3,000 monthly internal active users on the platform, and that's of the 5,000 employees in the company. So more than half the company uses it on a monthly basis. And these people range from dev teams to researchers to support analysts. And what's more interesting here is that we have only around 200 data workers in the company. So that's folks whose primary job is to look at and deal with data. So the reason I think that this is so interesting is that because we've managed to build something that can support the vast number of casual users across the company, while also still catering to the very specialized data users as well. Now, the Lakehouse is used by all parts of the company. And what I guess is most interesting here is that the audience as well varies in terms of persona. So in one extreme, we have data scientists who are building out ML models in notebooks to best determine the routing of support tickets to the most relevant support engineer. And on the other extreme, we have business users in HR and talent acquisition, logging into Tableau, consuming dashboards, and tracking the full journey of candidates through from referral to joining to their tenure at Atlassian. And both of these use cases at their base are using the same data catalog, the same data stores, essentially the same lakehouse. So let's go back to the beginning of our journey and how we got here. And I like to imagine that there is a sliding scale between a data warehouse style architecture and a data lake style architecture, with the lakehouse being that sweet spot in the middle where you get the best of both worlds. And in the beginning, at Atlassian, we're very much at the data warehouse end of the spectrum. In fact, we had two distinct data warehouses designed with very different purposes in mind. We had our Postgres data warehouse, which was ultimately used as an enterprise data warehouse, powering our business intelligence and dashboarding needs across the company. Our users of this were typically finance, support, marketing, and other enterprise needs. We then had our Redshift data warehouse, which is used primarily to power our research and development. It was here that we shipped all of our clickstream data from our products and used notebooks and SQL analytics to understand the user journey and patterns through our products. Unfortunately, this came at a cost for us, and there were several challenges. Primarily, we noticed that a large number of data sets were typically being copied across from one data warehouse to another. These copies were brittle and often added delays to downstream pipelines and analysis. We faced several other problems with this data warehouse architecture as well. For one, there were differing syntaxes between the two data warehouses, which caused heartache for an analyst and using both systems and trying to convert queries between the two. Secondly, we're hitting concurrency issues, and Atlassian at this point in time was going through a period of hypergrowth, and the queries hitting these two data warehouses was causing us to do regular upgrades to the infrastructure. Lastly, there was a cost to pooling data from these two data warehouses together, and as a result, a lot of analysis just didn't happen because the engineering tax was just way too high. It was at this point that we decided to reevaluate our architecture and what we're trying to achieve out of it. We knew that data volume was going to be growing exponentially, and we wanted to build something that would scale well with Atlassian. It was also this point back in 2016, there were plenty of examples of S3 data lakes being blogged about and discussed in the data community. And following these examples, we decided to take the leap and combine both of our data warehouses into one data lake style architecture. And what we essentially built was an S3 based data lake and used Hive and Presto on EC2 and EMR to serve up data for various use cases. And the beauty of this was that we now had all of our data in one place. And this meant that there was less engineering tax in copying data from one store to another for any sort of analysis. This architecture was also infinitely scalable. We could always add more clusters or add more data to S3 without having to really re-architect our infrastructure. Unfortunately, performance was not on par with what we had in the data warehouse. We could manage to get relatively good concurrency with Presto, but smaller queries were still not returning as fast as they did in the data warehouse architecture. Also, modeling data for dashboards and BI use cases was quite difficult. Performing updates often meant rewriting entire tables or partitions, and we couldn't just run a simple update commands like we used to in the data warehouse. And lastly, there was a higher barrier to entry for data analytics and science use cases. Our data platform team, my team, was becoming the bottleneck for users wanting to do anything advanced on the platform, often with users having to ask us to add them, create them a cluster or add particular libraries to their cluster. It was at this point back in 2018 that we discovered Databricks. And even though the lakehouse paradigm wasn't really a thing back then, adding Databricks moved us closer to that nirvana state. And in the grand scheme of things, not much actually changed when we added Databricks. We were still able to keep all of our data in our own S3 buckets, and we're still able to use the AWS Glue data catalog to store all of our table definitions. What did change, however, was the experience that Databricks added on top of the data lake, which brought us closer to that lakehouse architecture. We were now able to perform queries much faster, thanks in part due to Databricks' optimized runtimes, but also as a result of the optimizations that came with converting tables to the Delta Lake format. This meant an improved experience for business intelligence style use cases. In recent months, we've also been fortunate enough to trial Databricks SQL, and we see that this will further improve the slice and dice experience for our users. Delta Lake also allowed us to bring back database style commands, such as updates, deletes, and merge statements without having to really worry about the complexity of managing files in S3. We could essentially start treating the data lake like a database by this point. And perhaps the most unexpected outcome for us was that our analytics platform team was no longer the bottleneck for any sort of data analysis or science use cases across the company. We could essentially just give our users a cluster and they could be completely autonomous to configure it to their needs. Lastly, with Databricks, we remain on an open source platform, which has two major benefits for us. For one, we're able to spin up compute outside of Databricks to achieve whatever we need, given that data still resides in our own S3 buckets and in an open source Delta Lake format. And secondly, we're able to take advantages of the innovations that are happening today in the data community, in the data space. Now, this is all really exciting, but what's more exciting is the impact that the data lakehouse has had on our business. To start, we've seen a large cost reduction when compared with both the warehouse and data lake architectures. As an example, with all storage on cheap S3, we aren't paying to keep disks warm when data isn't being accessed as frequently. But also thanks to the highly optimized Spark runtimes, our pipelines are ultimately quicker and take up less CPU time. Secondly, our data engineering team can be more focused, as there is only really one platform to work on. This ultimately means less context switching for them and a narrower job profile to search for when looking for new hires. We also felt that data governance has been made significantly easier, as there is ultimately just one thing now to secure and apply controls to. And lastly, our data scientists, analysts, and engineers are ultimately more autonomous. We've essentially handed the keys over to them and let them be free to discover the platform on their own. And this in itself has been a significant accelerant towards innovation within the company. Now, I believe we're getting super close to hitting that Nirvana lakehouse architecture state. And I feel that Databricks will help us get there faster. Some of the most exciting things that we're doing in the coming months are moving more BI-style workloads towards the Databricks SQL endpoints. Being a relatively new feature, we are yet to really move everything across just yet. We're also planning on moving more tables towards Delta Lake to further improve their performance, but also to simplify workloads that need strong dimensional modeling. And lastly, we're looking at ways that we can enable more sensitive use cases by using Immuta, which is a self-service data access and privacy control layer on top of our data lakehouse. So to recap, We at Atlassian have proven that there is no longer a need for two separate data things. Technology has advanced far enough for us to consider one single unified lakehouse architecture. Secondly, we believe that the Databricks platform has the capabilities to make this convergence of warehouse and lake even more possible right now. And lastly, we've been successful in this move towards this lakehouse architecture by essentially handing over the keys to our teams and letting them be free to explore, make mistakes, and essentially be fully autonomous. And I personally feel that this is one of the first steps to really winning with the lakehouse architecture. Some final words before I finish up. Firstly, we're hiring data roles in the US, Australia, and India. So you can check out our site for any upcoming opportunities. And secondly, we have other talks happening during the Data and AI Summit. You can check out Isha and Richa's talk on Wednesday at 5 p.m. PST, discussing how they've built scalable data pipelines using Databricks. Thanks for listening, everyone. Back over to you, Ali.
Thank you, Rohan. Really innovative work by you and your team. Open isn't just about open source. It's about access. It's about sharing. As an industry, we often talk about how data is the lifeblood of every successful organization. Increasingly, the road to success is about how data flows between organizations. Data needs to be gathered, organized, exchanged, and enriched to take on bigger and more complex opportunities. But the systems in place today haven't actually allowed this to happen. Historically, getting access to data has been very difficult. Data sharing solutions have been tied to a single vendor or a single commercial product, introducing vendor lock-in risks. And this approach has been the same since the 80s. Data vendors say, store all your data, ETL it to ISV1, and share it with anyone. This is great as long as everyone buys and adopts ISV1. But over time, ISV2 came up with a better speed, then ISV3, and then 4 had better price, easier to use. So ISV1 isn't the only vendor. And now the data lives in many different systems and they're siloed. Even from the vendor's perspective, it's a nightmare. What vendors want is for the data to be easy to consume, but now it's hard to consume and a nightmare to manage 10 connections securely. The world has also changed. The only way you could talk to these systems back in the day was JDBC, ODBC, or SQL. But today, there's a plethora of data sources: video, audio, data files. SQL is still the only language to talk to this data, a language from the pre-big data era. It's not built for this kind of unstructured or semi-structured data, where Python has really become the lingua franca. So as a result, the community is stuck. What we need is a way to connect all the data stores and all data types with language flexibility to allow data practitioners to use the tools that they prefer. An open future demands an open approach to data sharing. This is why I'm really excited to announce Delta Sharing, the industry's first open protocol for secure data sharing. It's fully open without proprietary lock-in, not restricted to SQL, but it supports SQL and it supports data science. It's easily managed, privacy, security, and compliance. Delta sharing will be part of the Delta Lake project under the Linux Foundation. It'll be able to tap into this wide variety of support that the community already has for Delta. In fact, we've already seen tremendous support for the project. Providers including AWS Data Exchange, NASDAQ, FactSet, Standard & Poor's, and others have announced that they will make over 1,000 datasets accessible through Delta sharing. Additionally, Microsoft, Google, Tableau, Starburst, and many others have announced that they will integrate support into their products. Now to tell us more about Delta sharing, please welcome Matej Zaharia, co-founder of Databricks and creator of Apache Spark. Matej, I'd like to share these Legos with you.
Oh, thanks, Ali. I love Legos. So I'm really excited to talk today about Delta sharing, the open protocol we're launching for secure data sharing that will make it as easy to share data securely as Ali and I just shared these Legos. When we designed Delta sharing, we had 4 big goals in mind. First of all, we wanted to make it easy to share existing live data that a company already has in its data lake or lakehouse without the need to copy it out into another system. And the reason for this is simple. Most data in enterprises today lands and is processed in a data lake. And so this is where you already have your freshest, newest data. So we wanted to make it easy to share exactly that with downstream customers and not have to move it into something else and introduce delays and potential errors and gaps in the data. So that was the first goal. Second, we wanted to make this data easy to consume in a wide range of clients. And we do that by leveraging existing open data formats such as Apache Parquet. And the goal here is so that when you share the data with another organization, the users in that organization should ideally be able to connect the analytics tools directly to the Delta Share without requiring any help from IT, for example, to set up a new data warehouse and give them permissions to get into that and so on. So we really wanted to reduce the friction for consumption if you just have a user that you want to share the data with. And we're doing this through the open source and commercial partners for the project who are going to support making that super easy. Third, we wanted strong security, auditing, and governance controls built in because we know it's very important to have tight control over how you're sharing the data. So we've designed the protocol to allow that. And finally, we wanted Delta sharing to scale efficiently to sharing massive data sets. We see a lot of use cases where organizations are sharing terabytes of data with their partners because it's fine-grained industrial data or financial data, or in general, it's just a large data set. And we wanted to make sure that this is super efficient. And this is one of the places where a lot of data providers we talked with, had challenges scaling legacy solutions to really work with these large data sets. So how does Delta sharing work? There are two parties involved. There's a data provider and a data recipient. So the data provider can start with an existing table that they have in their storage in the Delta Lake format. And if you're not using Delta Lake and you're just using Apache Parquet, it's also very easy to create a Delta table that points to your existing Parquet data. So they don't have to do anything to the data itself. And then in front of that, they can run a Delta sharing server. So this is what implements their side of the protocol. And basically, in the Delta sharing server, you can decide, which recipients have access to which subsets of the data, and you can set up access permissions, and that's what this enforces. Now, on the data recipient side, they can actually run any client that implements the Delta sharing protocol. So it could be Apache Spark, could be Pandas, could be Tableau, could be a wide range of systems that are supporting this open protocol. And the provider doesn't need to know what they're running. They just connect to the server and they get access, to the subset of the data that they're allowed to get to. So how does it actually happen under the hood? So what will happen under the hood in the protocol is that the data recipient, when they want to access a table, they'll start by sending a request to this data sharing server. For example, let's imagine that the provider here is a retailer, and it wants to share real-time information about items being sold in its stores with its suppliers. So it might share a table called sales with each supplier that shows them what's being sold so that they can do capacity planning and they can produce the exact right items at the right time. So then the recipient asks to query that table. Now, the first thing the server is going to do is check the access permissions and see whether this access is allowed. And let's imagine it is actually allowed in the permissions you set. So next thing it's going to do is it's actually going to look at the contents of the underlying table, which are objects or files in a cloud storage system like Amazon S3. And a key thing that the Delta sharing protocol supports is it actually allows the recipient to ask for just a subset of the table. For example, I just care about sales of this one line of products. So the server can actually look at these files and smartly filter down which files in the cloud storage system, S3 in this case, but it could be your favorite cloud, are relevant to this specific query. And then the final step is to transfer the data back to the recipient. And this is also where we do something pretty interesting. And we actually leverage the capabilities of the Cloud Object Store to make this transfer very fast and parallelizable and low cost. So the way this step works is that the server actually generates these short-lived URLs, such as pre-signed URLs on Amazon S3, that allow the client to request, just those specific files that they're actually allowed to get for this query, and it sends those back to the client. And then these are just HTTPS URLs, and so the client can then just open them and start reading, and it will actually transfer the relevant objects directly from the Cloud Object Store. This is really nice because it means if you're sharing a massive data set, you don't need to stream that through a server and have huge infrastructure sitting around that can do this serving reliably. You can actually use some of the best, lowest cost, most reliable infrastructure on the planet that you have in these cloud object stores, and you just defer to them to transfer the actual data. And so it's heavily optimized, and it's likely going to be the cheapest, most reliable way to get this data to many of these recipients. So that's how the protocol works. This design has a number of really nice benefits for both the provider and the consumers. So for the provider, first of all, they can easily share data they already have. And in fact, it's also possible to restrict it further. For example, Delta Lake actually versions the files that are part of each version of the table. And so you can actually easily share just one specific version of it. For example, today's snapshot. And then while you're changing the table in real time, the recipients don't have to see the latest changes unless you want to. In fact, you can even share just one partition of the table to give them access to just one subset of it. And you could even share, for example, a view where you filter the table, and we would compute those filtered data files in real time. So it's very flexible in terms of what you share. At the same time, as a provider, you can share a table live if you want to share the newest data, and you can actually update the table reliably anytime you want with ACID transactions because Delta Lake supports that, and then clients will always see a consistent view of the table. So you can do that kind of real-time, consistent sharing use case as well. Now, for the clients, one really powerful property of this protocol is that it's very easy to implement a Delta sharing client if you have a system that already knows how to read Parquet, because all you have to do is make one call and get that list of URLs and then read them. So this is why we see already so many open source projects and commercial systems that support reading from Delta shares, because all of them support reading Parquet as an open format, and we just leverage that and let you share now these subsets of a table in real time. So it's super easy for clients to implement. Most data analytics systems out there already support Parquet, so we anticipate it'll be very easy to support this. And finally, for both parties, the transfer is fast, cheap, reliable, and parallelizable because it's using these massive cloud object stores. So even if you're sharing a terabyte of data and someone wants to read all of it, that will actually happen using something like Amazon S3 or GCS, and then the client will be able to read all those URLs in parallel, and you'll be able to get a very high transfer rate. So the scale of your table should be no limit if you want to establish sharing across organizations. Okay, so that's a bit about the protocol. As Ali said, we're really excited about the ecosystem that started to build around this already. We're releasing connectors with a whole bunch of open source projects, and the community is already starting to write some as well. For example, Scribd has written a connector for their R interface to Delta Lake to support Delta sharing. We're working with a number of other companies too. And we're also seeing many of the leading commercial vendors in data management and analytics support this as well. So, a lot of the major business intelligence vendors, analytics engines, and also quite a few governance products that will allow you to centrally manage what data you're sharing and anonymize it and so on. All of them are supporting Delta Share. So if you share a table this way, your users can use any of these systems to connect to it, which is super powerful. And finally, we're really excited about the traction that we're seeing from data providers as well, where many of the leading data providers are backing up this project and will make it possible to consume their data really easily in this very wide range of data analysis tools through this open protocol. So we really think that the future of data sharing is open, and we think Delta sharing is going to be a key part of that. Of course, we're also implementing Delta sharing in Databricks. So if you're a Databricks customer, you'll get a secure Delta sharing server integrated just as part of our service. And that will allow you to set permissions about who can access data, manage recipients, and also get fine-grained audit logs about who is sharing data, who's consuming it, and so on, that you can use, for example, for compliance and for billing. And as the interface for this, we've made the interface super simple. You'll be able to create and manage shares just in SQL using the new create share command that we're adding. And we also have REST APIs that allow you to do this programmatically if you want an application that actually manages all the sharing. So at the bottom, I'm just showing the syntax that an administrator could use in SQL. If they have an existing Delta table, they can just run a few commands in Databricks. Basically, they can create a share object, which is a collection of data that we want to share, and they can add tables into it. And then they can just grant permissions to recipients on individual shares using a standard grant statement. And Databricks will run a sharing server in front of the table just as part of our platform that will do the secure sharing and auditing, and then clients can connect to it from any system that they want. They don't have to be Databricks customers or users. You can just connect, for example, Tableau directly to this and start consuming the data without any help from an IT team or other data infrastructure to get this in the hands of that user. All right, so that's enough about Delta Share just in terms of talking. I also want to show you Delta Share in action so you can see how easy it is to consume in a wide range of analytics tools. All right, so I'm going to show just how easy it is to get started with Delta sharing. What I'll do in this demo is I will configure some data to be shared inside Databricks, and then I'll show how to consume it from a wide range of other clients, from even organizations that are not using Databricks that just want to connect to what I'm sharing. And in particular, I'm going to pretend here that I'm working at some kind of health organization, and I want to share real-time data about COVID vaccinations I've collected with a whole bunch of other organizations, governments, hospitals, and so on. I've actually put in a data set into my Databricks workspace that is actually some real-world vaccination data from our world in data. And I'm just going to show what that looks like so you get a sense of it. And then I'll show how to share it. So this is the data set I have. You can see, it's sort of this table that has basically for each country at different points in time, how many COVID cases they had, how many vaccines they gave, and so on. And you can use this to plot a lot of interesting data about what's happening. Now, this is just sitting in my data lake as a Delta table. So what do I have to do to share it? So the first thing I have to do is to create a share object. This represents a collection of tables that I want to share with someone that I want to give a name to. So I can do create share vaccine data, and it just creates it. And then I can add this table into it. And I can just put it into the share. And if I want, I can put multiple tables into a share and actually share them together, so that's fine. So maybe I have another table here about the distributors of the vaccines, so I've put that in. And now I can just describe this and see that I've got the correct tables inside it. So this looks like the stuff that I wanted to put. Okay, so the next step is to give some credentials to all of the recipients that I want to share the data with. So I'm going to just show adding one recipient. And let's say this is the CDC in the US that I want to share this data with. So I can just do create recipient. And what you'll see here is it gives me this activation link that I can email to my contact at the CDC or otherwise transfer to them that lets them actually download some credentials to access this share. So let's see what that looks like for them. I'm just going to this link here. So okay, so you'll see, they have this big button here to download a credential file, and then there's information on how to access this share directly in, their favorite data analytics tools. They don't necessarily have to use Databricks. They can just directly connect to it without setting up any other kind of infrastructure. And then when you download this, you just get this .share file that you can then pass into the different tools. Okay, so the final thing I have to do to actually share the data with this person is grant permission to this recipient on the share that I created. So I can just do that with a grant statement. So I can just do that. And now they have permission to access it. Okay, so what does it look like now for someone working at the CDC to access it? Turns out that they can access it using any of a variety of tools that they might use, and it's really easy in each of the tools. So I'm just going to demo a bunch of the ones supported. So the first thing I'll start with is actually Amazon Elastic MapReduce. Now, EMR, is obviously a hosted system that can run Apache Spark in the cloud, but it actually doesn't have built-in support for Delta sharing right now. Nonetheless, this isn't really a problem because the Delta sharing client is open source, so I can easily install it. It's just a data source library that you can install into your Apache Spark cluster, and then you can start connecting to this Delta share, even though this user is on EMR and I'm sharing the data from Databricks. So I have a notebook here that shows how to do that. I'm just going to open that. And let's see what a user has to do in EMR to access this data. So the first thing the user can do is just import Delta sharing. This is the Python client library we've got. And then they can start accessing it based on that credential file that we gave them. Let's start by listing what files have been shared with us. So I can build this sharing client. And I have the table here. I have the credential file that I gave to this user. And I can just list all tables. And you can see there are the two tables I put in there, vaccinations and distributors. The other thing I can do is I can just load the table as a Spark data frame. So to load the table as Spark, I need to pass in the credential file. And then I need to say which table inside it, and I can do that in here. So it's in the share called vaccine data .vaccine data.vaccinations. And so I've created this Spark data frame here. So now I can just look at this data frame. You can see it's a Spark data frame that has all the columns in there, and I can do analytics on it. For example, I can count how many of these records are in the share, and this is accessing the data that I had in Databricks. It's accessing it directly through S3, and it's allowing this job to process it and to count these. So very easy to connect to it as if it's any other Spark data source. You can just connect to it in your favorite tool. Okay, so that was EMR, but that still requires someone to set up Apache Spark. What if I have an analyst who just wants to work with this on their laptop, for example? It's not a problem either. You can actually just connect the to Delta sharing in Pandas as well. So here's another Jupyter notebook I have that's just running Jupyter on a single machine, and I'm going to show how to connect to it from Pandas. So I can do, so again, I will pass the path to the .share file I have. So in here, it's in home. So I can just pass in, the path that I want to load. And now it's given me a Pandas data frame. And if I want, I can print this data frame, and I see all the same records that I was seeing before with the different countries, all with the correct schema. And I can go ahead and do whatever analysis I want in Pandas on this. So super easy to connect it. All right, finally, I'm going to show how to connect some business intelligence tools directly to this so that if I have a user who's an analyst who doesn't want to write code at all, they can also work with this share, again, without asking IT to set up a separate data warehouse for them and load the data into it or to do anything else to access the real-time data. All right, so let's start with accessing the Delta share in Tableau. I have Tableau here, and I can open the connector for Delta sharing. And just open that and then select my .share file that I downloaded in there. So again, this is the one I got from the activation link. And then I can open this data set inside Tableau, and I see the same table, vaccinations and distributors. So for example, if I want to work with the vaccinations table, I just load it in there. It's going to load it through the open protocol into my instance of Tableau. And then I can just, take some of the data and begin plotting it in Tableau using my favorite tool. So I don't need any help from IT or anyone else to set up some infrastructure. I'm just working, with the latest data that's been published by this health organization. So for example, maybe I want to make a map, and using this data, I want to plot, for example, the amount of people fully vaccinated in different countries. And let's show this a max here, just show the maximum they've gotten over time, and then use that as a color in my plot. So I've just made this visualization in a few clicks from the data that's being shared in real time. And finally, let's try the same thing in Power BI. So again, I open Power BI and I look for the Delta sharing connector. And I can put in that path that I had earlier with my file. And again, now I can browse the share, see all the tables inside it, and pick one of the tables and just start working with it in Power BI with just a few clicks. So we're loading the vaccinations table here, and then I can actually just take some of the fields in it and start plotting them. I'm going to plot the date, and I'm going to plot new cases and also new vaccinations over time and show how those trends are changing over time, specifically in the US. So this is the new cases. This is the people fully vaccinated. And let's also filter it down so that the location is in the US. And you can start to see here, cases have started going down and vaccinations have started going up quite a bit since the beginning of the year. So super easy to just take this data, connect my favorite analysis tools to it, and just start working with it without any other infrastructure. Okay, hope you enjoyed that demo. So that shows what's possible with Delta sharing today. We're actually just getting started with the project, and we have a really exciting roadmap ahead for the open source project. So we're working on a number of things. First of all, we envision this protocol to allow sharing many other kinds of objects as well, not just static tables. For example, Delta tables can already be viewed as a stream. They already do change data capture, where you can see what was added and removed at each version. So we want to allow sharing a table as a stream, so you can have clients that just look at what's changed in a data set if you want that. And that's an easy extension to the protocol. We're also looking to add machine learning models from MLflow, table views, and arbitrary files as objects that you can share, so you can really share any subset of your data and any kind of object that you want with organizations and have great support in all these systems that can connect to it. We're also working on the governance side on a bunch of exciting capabilities. So for example, we want you to limit the amount of time that something is shared for, so you'll be able to set these controls. And we also want to allow easily sharing something in a restricted clean room analytics environment, where basically the user can only work with it in a specific interface, for example, to do data science or SQL, but can't exfiltrate out all the data. So these are all things that we can support on top of the basic protocol. So you can get started with Delta sharing today. We've open sourced it just today, and it's actually part of the Delta Lake 1.0 release. And we've currently released a reference server that you can use to try out the protocol, and clients for Pandas, Spark, and Rust. And we're also working on a whole bunch of other open source connectors, and we're working with our partners on the commercial connectors that will directly support this in a wide range of projects. So you can get started with this today at delta.io/sharing. There's a tutorial there, so you can just walk through it and see what it's like to use this. And we're really excited to see what use cases you enable using the Delta sharing protocol. All right, well, back to you, Ali. Thanks for sharing the Legos. I wanted to share something I got today at the lake. Looks delicious, and you look a little bit hungry, so here you go.
Thank you, Matej. So we're obviously very excited about all of this innovation and the rapid adoption of the lakehouse architecture. But we're not the only ones that are seeing this new pattern unfold. So I'd like to have a chat with Matt Garman, Senior Vice President at AWS. Matt, super excited to chat with you. Thanks for doing this.
Yeah, absolutely. Thanks for having me.
So I got to start with EC2. legendary service that became the foundation of all of Amazon Web Services, and you're one of the masterminds behind it. Can you take us back to those days? Tell us some inside stories. Were there any doubts? How did you guys come up with it? How did it go down?
Yeah. Well, yeah. So as you mentioned, I actually joined AWS in 2006. It was right after we had launched S3 and just a couple of months before we launched EC2. And it was a fun time. And, I think at the time, I don't think any of us had any idea how fast or how quickly the business would grow. But, we always knew it had a lot of potential, and we knew that folks were super interested in the idea of these on-demand services. And we thought they'd be compelling to a wide range of people. And, I remember early on, I think almost every conversation that I had started out with, why would I buy compute and storage services from a bookseller, an online bookseller? And we'd have to walk them through how Amazon had built up this capability and why it made sense to buy them from us. And, eventually people got over that. And I remember one story in particular. I was sitting down with all the tech leadership actually at one of the biggest banks in Wall Street at their offices in Manhattan. And they were super interested in this new idea of cloud computing and what it was. And so we went through and explained how it all worked. And at the end of the meeting, they basically told us there's no chance that any big bank would ever put a production workload and run it outside of their own facility. Now, of course, fast forward 15 years later, and Goldman Sachs and JPMC and Barclays and Capital One, they're all running these large production workloads in AWS. But at the time, and it took us a long time to get there at a time, and they didn't see it. And we had to work with them. We had to help them reinvent themselves. We had to invent a lot of cool stuff along the way that made that possible. And part of that was inventing kind of this broad set of services that we have in AWS today. And that's why those banks and others in all sorts of industries are now running on AWS, is because we have this broad set of compute offerings that's really the broadest out there, including things like custom CPUs and custom machine learning accelerators like Graviton2 and Inferentia that we make that give customers like a 40% price performance benefit over anything else they can do. We have things like 400 gigabit networking that help their big data workloads run better. And those type of innovations, they really kind of change that price performance gap and that really capabilities gap for some of the biggest customers in the world, as well as some of the earliest startups. And for every type of workload in the world, whether they're just pure compute, data analytics, and machine learning. And it's one of the reasons why the vast majority of machine learning is done in AWS in the cloud today. And it's a big part of why we have thousands of joint customers together.
We're super excited about Graviton2 and all the interesting innovations that are coming in. What was actually the thing that made some of these banks eventually come around?
Yeah, there's a couple things. I think one of them was that price performance benefit, where they saw that they could actually get both the price performance benefits as well as the scale. And it turns out they value agility. And I think David Solomon said during one of our conferences, the CEO of Goldman Sachs, that they actually have more software developers at Goldman Sachs than they have bankers. And so just like a lot of developers out there in other industries, their developers wanted that agility. They wanted to be able to move quickly, iterate quickly, take advantage of new services and capabilities. And as we started bringing out this breadth of services, they started to realize that there was a lot of benefits there, and they could focus on how do they build better risk models and how do they build better trading platforms and other financial instruments, and less about how do they manage data centers. And we had to go through all of the compliance pieces and other things like that helped get them there. But now they're happy customers and growing rapidly.
I'm curious, any favorite joint customers you have, that are leveraging Databricks, that's then, in turn are leveraging all of the infrastructure that you guys have and all the other services?
There's a ton of them. I can name a couple, and it's been fun. I think one thing I'd call out is it's been fun working together with you and the team over the last since 2012. I think you said, so the last 9 or 10 years. It's been great to see your company grow, and that partnership has been great for us. I think if we look at our joint customers, one I'd call out is John Deere. And one of the things, they're a super mature and industry leading analytics company, and they really think deeply about how they can use data to better further their company. And so one of the things in particular is they had a self-managed Hadoop cluster that they were running, and they decided to migrate that onto Databricks on AWS. And one of the cool things about them is first, they were super dedicated in thinking about how do they do that in a secure way, in a highly available way, and how they could add value to the business. And since they've migrated onto Databricks and AWS, they've done some really cool things. I think one is they really wanted to get better cross-departmental analytics. So they had a bunch of data silos all throughout their company, and there's a bunch of different places. And they thought that there was an opportunity to get better insight if they could put that all in one place. And so they did that. They put it all together, and now they're starting to see how they can play with price elasticity for their products to better manage their business. They're looking at opportunities to optimize their inventory, and they're looking for insights and ways that they can improve the customer experience. Another cool thing they've actually built is this thing they call agricultural analytics products. And what they do is they actually incorporate information from satellite telemetry, from data about the soil and the weather and how many acres you have and all of these other pieces, including even like maintenance information about your particular tractor or equipment. And they put all of that information together and give customers some interesting insights into how they're using their products so that they can actually get better utilization out of their John Deere products. So that's one really cool example. Another one I'd call out, kind of completely different industry is Comcast. Also had a really large on-prem Hadoop cluster that they migrated to Databricks on AWS.
Yeah, that's fascinating. I'm super excited about John Deere because it's a company that you wouldn't necessarily expect that they would be so much in the forefront of data and AI. And similarly, also excited about Comcast. So data and AI, like now, we're moving higher up in the stack. I mean, you started with EC2. You guys offer a lot of different services now. I think AI and data is a big focus for AWS.
Mm-hmm.
You also embraced this paradigm, the lakehouse, and talked a lot about it. Can you tell us a little bit about what you see in that space around data and AI, the lakehouse, and what customers are doing?
Yeah, to me, it's a fascinating space. I think it's super interesting to see everything that's happening right now, and particularly when you think about the intersection of data and different data stores that are out there, and then analytics and machine learning, as you call out, it's super interesting. And if you think about data stores, right, historically, you just put everything into a relational database and you would call it a day. But data stores are being completely reinvented around the world. And particularly as customers think about the explosion of data, right? They used to deal in just gigabytes, and now it's terabytes, petabytes, exabytes. I have customers that are even talking to us about yottabytes of data, which I had to go look up and see how big it is. It's hard to even think about that much data. But if you think there's predictions out there that in the next 3 years, there'll be more data created than in the last 30 years combined. And so there's an incredible amount of growth, and it's only accelerating. And so, the world is reinventing these data stores because historical data stores just don't work anymore. You can't just stick everything in a relational database. And so we have to continue to reinvent how everyone can manage this level of data. And it turns out that scale of data management can really only be done in the cloud. You can't really scale your on-prem data centers to handle something like that. And in AWS, customers are able to take advantage of virtually unlimited storage and a huge range of analytics and machine learning capabilities that help them unlock value from that data. And so we're actually seeing hundreds of thousands of customers today use AWS and really leverage partner solutions like Databricks to really figure out how they get value from that data. And so, as you mentioned, we see these customers that are embarking on these data strategies, and they're starting to build these data lakes as one central place where they can have all of their different disparate data sources. They want to have a place where it's easier to have this discovery, governance, the right level of access. And it turns out that the majority of customers around the world actually start and leverage S3 as the core of their data lake. Now, these customers want to be able to have a couple of things when they think about their data strategy. They want to be able to make decisions quickly, and they have multiple organizations that need to be able to store large amounts of data in a variety of open formats, and they want to break down these disconnected data silos, right? It's a killer for a lot of enterprises where they just have data locked up in different places. And then they want to empower their teams to easily run analytics and machine learning with whatever their preferred tool is or whatever preferred technique is. And they want to have the right security and management things so that they can control who has access to which data and who's allowed to see which data and have the right governance on top of their data.
Is it fair to say, I think Werner Vogels talked about your internal, how you guys at Amazon internally actually organize all your own data. I think he referred to it as a giant lake. Mm-hmm. Is that a lakehouse paradigm?
Yeah, that's exactly, and that's how we talk about the lakehouse paradigm, where we have a bunch of these analytics services kind of around with S3 in the middle. And so we add capabilities to S3 to make it easier to use this scalable data lake. But really, it's these purpose-built data and analytics platforms that allow you to kind of get that interesting insight into that data with various different types of performance and cost capabilities.
The theme this year about the conference is that the future is open. And we just announced open technology around sharing of data sets in a secure fashion. So it's open source. Delta Lake will contain Delta sharing. And we have one of the premier partners of that being AWS Data Exchange, supporting that protocol. How important is data sharing securely between organizations and different BUs? And what's the significance of data sharing in AWS Data Exchange?
Yeah, no, we love that. I think it's a super exciting announcement you have. So congratulations to you and the team. We built the AWS Data Exchange because our customers were telling us that they wanted a better way to easily license and share data, both in proprietary formats and open formats with each other. And they were using these kind of antiquated methods of FTPing files around and literally shipping hard drives back and forth to each other, and it was just too much work. And so today, as an example, many of our customers have this situation where because of COVID, they have a bunch of uncertainty in their business. And many of our customers are actually using a variety of third-party data sources via the AWS Data Exchange around things like location, aggregated data movement, consumer spending patterns, and things like that. And they'll leverage them from vendors like Foursquare or Factious and to better understand and make decisions on when and where to reopen various businesses or how they forecast demand in various uncertain times. And so I think there's a huge opportunity for the sharing of data, both in open data sets and as well as open formats, as well as proprietary data sets that can be layered on top of those. And I think our goal is to make it easier for customers to share data in whichever way they want, whether it's licensed or just open. And we love to see that. We're excited to hear more about how our mutual customers can use data exchange and Delta sharing together. And so we're excited to see where it goes, and congrats on the launch. That's exciting.
Very, very excited to partner with you, Matt. Thank you so much for joining us today.
Yeah, thank you for having me, and great talking.
It's really, really exciting to see all the excitement around Delta sharing and the lakehouse from our partners like Matt. The key to these innovations is Delta Lake. And one of the core workloads for Delta Lake is ETL or ELT. It's one of the most critical data workloads because data quality affects every downstream workload. Now, as new data is brought into organizations, data engineering teams have the jobs to process this messy data into clean, fresh, reliable data that fit the use cases that it was intended for. Often, this gets represented as a clean flow, but the reality is not so simple. The exponential increase in data sources and types happening inside enterprises means building and maintaining reliable data pipelines has become one of the more challenging parts of the whole data science and the data engineering work. The fragility of it all creates huge challenge for maintaining reliability. If a pipeline fails, it has huge downstream impact on all of the systems and the teams that rely on that data. This makes poor reliability extremely expensive. That's why I'm really, really excited to share with you a new project called Delta Live Tables, reliable ETL made easy on Delta Lake. Delta Live Tables understands the full graph of all of your pipelines. It understands the semantics of all of the transformations. It can schedule, run them, it can monitor them. If they break, it can relaunch them and make sure that they're reliable. It can automatically manage the infrastructure and everything they run on in a serverless manner. It can automatically connect the data that's flowing through your pipeline, and it can even test your data as it understands the data. It can let you make updates while the pipelines are actually running live in production environments. To tell us more about how this is done, I'd like to welcome back Michael Armbrust.
Thanks, Ali. We've all been there. As a data scientist, you get a request from the CEO. He expects some really important analysis that is going to change how the business moves. And of course, they need it ASAP. So what is your job? You're given a whole bunch of JSON files stored out in cloud storage, and you're expected to quickly turn it into an interactive, explorative dashboard that will help them decide which direction your company should go in. And this is a pretty common problem. And I think most data engineers are pretty good at the first couple of steps. You often start with SQL, and I'm just going to write this create table statement that loads in that raw JSON data and puts it into a table. And next, I'm going to do some transformations on it. Again, pretty easy with SQL. So I'll go ahead and read from that raw data, I'll parse timestamps, I'll join, I'll aggregate, I'll do some things to get it ready for analysis. And I can run all of this on top of Spark and Delta Lake. Pretty easy, right? Well, this is where it gets hard. They never want it just once. They want it to be updated over and over again, every day with the freshest data, so they can continue to use these insights to power the organization. So you're going to have to start worrying about dependencies. I need to make sure that I run different jobs regularly and that the raw data table is always updated first, and then the clean data table is always updated second. You're going to realize that you can't recompute these tables from scratch over and over again. So what most people end up doing is, rather than work on entire tables, they work on partitions. They break it up by date, and then they build an engine that both understands these dependencies and can update individual partitions in the correct dependency order. As soon as you start building this, it gets a little bit more complicated because it never works on the first try. There's always transient failures in the cloud or other networking problems. And so you need to build checkpointing and retries so that if something breaks, you can pick up from where you left off and you don't lose lots of work due to simple transient errors. And let's say you get all of that working. Well, even if you're really good at SQL, you still need quality checks. You need extra jobs that run on top of these results to make sure that they're correct. You need to set up monitoring and alerting so that if the quality checks are failing, you get paged so you can come in and fix it. You need governance. This is sensitive customer data that we're working with. It might contain PII or other regulated information. And so we need to build a whole system that tracks how data moves throughout the system so that I can report to regulators and make sure I'm meeting all of my requirements. You also need data discovery. I spent a bunch of time on this analysis. I want other people in my org to get value from the time that I spent transforming and cleaning this data. But in order for that to be true, I need to document it, and I need to keep that documentation up to date. I don't know if you ever tried to find data by searching your company's wiki, but it's usually not correct. And then after you get all of this working, there's going to be a new requirement. There's some new type of analysis that needs to be done. And so you're also going to need to build a system for doing backfills, where you recompute all of this data from the beginning of time with some correction or with some new feature added on top of it. And as you can see, this is turning into a real engineering problem. So of course, I'm going to want version control so that if something goes wrong during that upgrade, I can always roll back to another version. And I'm going to want deployment infrastructure so I can easily take those changes that are happening inside of version control and push them into the cloud. But what you're going to notice here is the operational complexity is starting to dominate. I'm spending all of my time on tooling instead of transforming. And if I really want to be valuable for my organization, it should really be the opposite. The place you want to focus is on those transformations. You want to spend your time getting value from data. And that's why I'm really excited to announce Delta Live Tables. Delta Live Tables makes it possible to build production quality ETL writing only SQL queries. So you can see I took those having familiar SQL queries from before, and I've just modified them to add live. And the live tables runtime is going to take care of all of those operational, governance, and quality concerns. And what that means is, since you're spending less time on those tooling concerns, you can spend more time on getting value from the data. You can actually add extra transformations that tell your organization how the business is doing. And Delta Live Tables is not limited to just SQL. You can also mix Python with SQL in order to do advanced analytics and AI. So you can see in this example, I'm reading that clean data set and I'm handing it through a machine learning model, and I'm doing scoring on top of it. And you can use all of your favorite tools inside of Python to do this. We have full support for pandas, or for koalas, if you want a pandas-like interface. But you might be asking yourself, this sounds too good to be true. How is it possible? Well, the way Delta Live Tables works is we actually take those queries that you write out, and rather than just execute them against a database, the Delta Live Tables runtime deeply understands those queries. And what it does is it analyzes them to understand the data flow between these different queries. And once it understands the data flow, you can start doing some pretty cool things. One really cool thing that you get is this idea of environment-independent data management. What do I mean by that? You never want to have just one copy of your data. You're going to have your production copy, you'll have your staging copy, you might want a local copy when you're doing development. And because Delta Live Tables understands the lineage, and because this lineage is expressed in an environment-independent way, you see I'm not reading from a specific schema, I'm reading from the live schema, which is always correct and always up to date. So I can take the same set of query definitions and I can run it in development on my laptop against a small data set to see if things are working. I can run it in staging against a larger data set that, maybe the last couple of months worth of data to make sure that all of my analyses are working correctly. And then finally, I can deploy that same code with no changes into production. And I can do that with confidence because I've already validated that it works in these other environments. One of the really cool ideas that we're leveraging here that's been popular in a lot of data engineering projects recently is the idea that you should be treating your data as code. It should be a single source of truth for what's going on inside of your data warehouse. And I believe that this should be more than just the transformations. Some other things that should also be included in that code that defines your data are things like data quality expectations. So Delta Live Tables also adds this thing called quality expectations, which allow you to specify what makes bad data bad and how you're supposed to handle it. In this case, I've added a constraint requiring that there's a valid timestamp, and valid means, after some time period for my organization. This is more than just a traditional check constraint in a relational database because it has tunable severity. You can choose to just observe and record how much data is messy. You can choose to drop rows while recording how many rows are being dropped. Or if this is a critical table that you're reporting to regulators, you do have the ability to fail any transaction that tries to load bad data into the table. But it's better than that because we also use that lineage information that I talked about in the previous slide to capture which row caused a bad row to be outputted and give you that information so you can do debugging faster. Another thing that I think should be recorded along with this code is documentation. You should be able to tell other people in your org where this data come from, what it's used for, how it was transformed, and that should be stored alongside the actual transformations. That way, you're guaranteed that this information is always fresh and not stale. And finally, one of the nice features of Delta Live Tables is governance is built in. So when you record information about these tables, for example, in this case, I'm recording that this table has PII in it. That, along with all of the quality and operational information about execution, is automatically captured in what's called the event log. And you can use this information to record how data flows through your organization and also prove to regulators that you're meeting all of your requirements. So seems pretty cool, but rather than spend more time talking about it in slides, I'd like to jump to a demo and show you how it really works. So here we are in the Databricks workspace. And as you can see, we've got our kind of familiar create table as select statements here that are powering the ETL that we need to do. However, you can also see that this is a far cry from a production ETL pipeline. You can't just run the same CTAS statement over and over again. I could change this to create a replace table, but that would be horribly inefficient. We'd be re-ingesting all of this JSON data every single time we updated the pipeline. Instead, let's see how easy it is to turn this into a Delta Live Tables pipeline. So I'm going to start by saying create incremental live table. And what an incremental table is it's one that only processes new data that has arrived since the last time we did processing. And to do this, I'm going to use the Cloud Files source. Cloud Files is this really cool data source that can take any files stored on cloud storage, whether it's S3, ADLS, or GCS, and automatically ingest them with exactly one semantics, no matter how big the data set is. So we'll read from /data, and we'll say that it is JSON. And we'll go ahead and run this and get a preview of whether or not this works. So it looks like it's working. Data set looks pretty good. These timestamps don't look particularly normalized. Let's see if we can correct that in the next step. So now we're going to work on this table that takes the clean data and cleans it up. We'll make a couple of changes. I'm going to make this a live table as well. And I'm going to read from the virtual live schema. This virtual live schema is what allows us to do our dependency magic. This is substituted at runtime with the correct version of raw data for whatever environment I happen to be running in. So we've said create live table, seems pretty good. And we'll go ahead and run this to see if it works. Looking pretty good, but we're not quite done yet. We want to make sure that we have data discovery also taken care of, as well as data quality. So I'll go back here and I'll add comments. So I'll say that this is raw customer data ingested from JSON. And we'll go down here and we'll put a comment on this one as well. We'll say this is customer data with timestamps cleaned up. And I also want to make sure that I got that timestamp parsing right. I don't know about you, but that's something I often mess up. So let's put an expectation on this. So we'll say constraint, valid timestamp. This should be familiar syntax to anybody who has worked with constraints in traditional relational databases. And instead of check, we'll say expect. This is what allows us to have that tunable severity that we were talking about earlier. We'll say we'll expect that timestamp is not null. So now that we've taken care of our governance concerns, let's go ahead and make sure this is still correct. And then we'll switch over to the Delta Live Tables interface to actually run this. So I'm going to go over here and I will click Start the Pipeline. And what this is doing is it's taking that code that I just wrote. It's rather than just executing it against a database, it's analyzing each of those queries and building a holistic data flow graph that understands the dependencies between each of the tables. And this is not just a process that is going on here in the UI, it's actually also all being recorded into the event log. The event log is displayed here, but is also stored as a Delta table inside of your account. So you can come back and understand how this has been running in the past. And so we can see it has started execution, it's cited the graph. We've got a view of our two different tables, and this is running now. And while it's running, let's take a look at some of the data that's stored inside of the event log. So you can see it records all of the different actions that users take against the pipeline, as well as lineage and provenance information about the data that's being processed. So let's go ahead and take a look at one of these flows. So if we take a look at the raw data flow, we can see we have all of the details of where this pipeline is running, which pipeline it is, the names of all of the different flows, the schema that is being produced, the explain for the query plan that is being run. And so this is a wealth of information. And it also has that data discovery. And much of this information is also available here inside of the UI. So you can see exactly what this data set is, what it means, what its schema is. And we can see this one just completed there. Zoom in a little bit. And there we go. So it ran. But we're not quite done yet. I want to show a couple more things first. One thing we should take a look at is that expectation that we have. So let's go ahead and look at the quality information here. And so you can see we did a pretty good job, 99.1% of the timestamps parsed. So it seems like I just have a little bit of messy data that I can go and inspect later, but I can now publish this data set with confidence, knowing exactly what's going on under the covers. One other thing I want to show is incremental computation. If I run this pipeline again, it's going to do exactly the same thing it did before. It will go out, fetch that code, figure out the dependencies, but before it starts running, it's going to look at the checkpoints for each of these tables. So it will understand what data has been processed and what data needs to be processed. And so you can see the second run took only 5 seconds to complete. So a pretty dramatic improvement over 50 seconds in terms of efficiency. And this works for any streaming data source supported by Spark. Pretty cool. So just to summarize what we've seen here today, Delta Live Tables is a new system that's going to make doing reliable ETL easy on Delta Lake. It enables your data teams to innovate by giving them a very simple development experience where they're just writing declarative queries in SQL or Python. You can ensure accuracy with the addition of data expectations so that you know the data you're producing is high quality. And together, the fact that you're not dealing with all of these operational concerns anymore means that you can grow and scale your organization rapidly. If you want to see more, I encourage you to check out the public preview. There's a link on the screen. We're signing people up today. And now that I'm not spending so much time dealing with data pipelines, I can spend some more time hanging out at the lakehouse. Back to you, Ali.
Oh, thank you, Michael. Delta Lake. Being able to quickly and reliably produce high-quality tables in Databricks is going to have a huge impact on every customer. But all data is not created as equal. Today, customers are collecting massive amounts of data in data lakes in the cloud, and these data sets just keep growing. Fine-grained governance beyond the file level is really difficult to achieve. This leads to data lakes unfortunately becoming data swamps. Because you can only reason at the file level rather than at the file contents, you end up creating lots of subsets of the data just to get the right groups, the right access to the right data. It's a nightmare to enforce reliable governance. Of course, data isn't just going to be in one cloud, it's going to be in many. And the security APIs you have are low level and different across each of these clouds, which makes it really hard to keep everything consistent. This problem is just getting bigger and bigger. Most enterprises also want to share, audit, govern lots of data products like machine learning models, files, dashboards, and other data assets. There is no great way to solve this in a unified way today. That's why I'm really excited to share the industry's first unified catalog for the lakehouse, the Unity Catalog. The Unity Catalog provides one interface to govern virtually all data assets. It allows organizations to standardize on one fine-grained solution so that they can have one security model based on ANSI SQL for data lakes across all clouds. And the best part of this is that you can federate it so it works with existing catalogs, so there is no need for heavy migration. Now, I'm really excited to welcome back Matej to tell us more about the Unity Catalog.
Great. I'm really excited to introduce the Databricks Unity Catalog. So as Ali said, data lake governance today is unnecessarily complex. And a lot of the reason for that has to do with data lake storage systems that represent everything as files. So let's imagine that we have a bunch of users and a bunch of data in a data lake, for example, representing pages on the web or users on our website or something like that. The issue is that data lake systems themselves just represent this as a bunch of files. And whenever you set permissions to them, you have to do it at this very coarse granularity. For example, if we want to limit, which users can get access to which of the data sets here, we would have to look around and somehow make a rule about which user can access which underlying files and how those files map to the business rules that we're trying to set up. Like this is only about US data, for example, or UK data. And so when you set the permissions in these systems, you have to give these file level permissions. You might be able to set them on a directory or something like that, but they're about the low level, physical structure of the data. Now, when you have this kind of system, a whole bunch of problems start to come up. So for example, let's say that you're trying to set this up, and you have some users that should only be able to see a few columns or a few rows within your table. And so that is a subset of your file. Well, you can't do that with a file-based access control model. Either they see the whole file or they don't. So in all of the the data lake systems today, you have to be careful about what is in a file as a whole, and you can't have these fine-grained row and column level permissions. Even if you're OK without the fine-grained permissions, another challenge that might come up is, what if you want to change your data layout? Let's say you figured out a better way to organize your data that's going to make queries and updates a lot more efficient. For example, you can't do it without messing up your security model. You have to change the security configuration whenever you change the physical layout of your data. And it becomes very complicated to do that. And finally, what do you do if the governance rules in your organization change? You might have some change about what fields someone is allowed to access, and it actually requires you to rewrite all your data into a different format just so that you can have the right files and give permissions to the right files. So it's very inflexible and very complicated compared to what data management professionals are used to work with these. But the problem gets even worse when you look at how the data lake fits within the greater picture of analysis and machine learning at an organization. First of all, with most data lakes, you not only have the files, but you also have metadata. For example, you have a system like the Apache Hive Metastore that keeps track of table definitions and views. And so you have to give users permissions on that as well, which tables and which views can they see. And this can actually go out of sync with the underlying data. There's nothing guaranteeing that, if a user has permission on a file, then they have a permission on the corresponding table, or, if they're blocked from a table, then they can't get to the underlying file. So it's very confusing to manage. You have two different interfaces for doing this in two places. And most data workloads also involve other systems. So for example, if you're trying to run analytics jobs, and actually most of the data is in the data lake, but you also have something in a data warehouse, that's a SQL database that has a completely different permission model where it's not based on files anymore. And so you have to set the permissions on that as well. And it's very different from either the metadata or the files themselves. And if your users are also doing machine learning, you probably also want to manage a bunch of models, for example, using MLflow, and that has yet another governance model as well. So just managing data, managing access permissions, and getting audit logs of everything that's happening in a modern enterprise stack can be extremely challenging. So how does the Unity catalog tackle all that? The idea is actually very clean and simple. Basically, with the Unity catalog, we put a single unified object model in front of all the data that you might have in your data lake and in other data sources within the organization. And we give you a standard, an industry standard, and very flexible interface for configuring permissions, which is actually the ANSI SQL grant control language that you have there. So anyone who's administered a SQL database can actually begin administering these massive data sets in your lakehouse and make it really easy to control what people have access to. So the Unity catalog combines keeping track of metadata, things like table definitions and view definitions, with permissions. And it allows you to define tables and views that are backed by files, and it allows you to set permissions just on those tables and views using ANSI SQL at a fine granularity. You can set it on tables, rows, columns, or views. You don't have to think about what files each of those tables maps into. On top of that, with the Unity catalog, you can also easily add other data sources and get the same access control model inside it for your users to use. So for example, you can add SQL databases into them and start creating views or tables that maybe combine different data sets and have a single way of setting policies using attributes across all of this type of information. We are also supporting managing models inside the Unity catalog. So you can have models that are tagged, for example, as containing personal data or European data or something like that. And you can have a single way of governing them and the data that went into them. And of course, with Delta sharing, we're also giving you the same interface to manage data that's been shared with you and figure out who in your organization has access to these shares. So you get one unified governance model for all these types of data assets. And then the final benefit is that all of the accesses to these objects have to pass through the Unity catalog. And so we have a central place to audit all the accesses. And so you get this detailed audit log of what everyone is accessing. And you can much more easily implement compliance best practices through that as well. So how do you actually use the Unity catalog? Let's start by showing how to use it for tables. So the catalog is designed so you can actually take existing data you have in the cloud or in a data lake and start adding these fine-grained permissions in front of it. So you could just create a new table, that we build for you in your own storage bucket, but you could also create an external table that points to an existing location in S3 or ADLS or your favorite cloud storage system, and you can tell the Unity catalog what credentials, such as an IAM role, to use for accessing that, and then the catalog will be able to get to it, but all the permissions for end users will be these fine-grained permissions that you set using table and view definitions in front of it. And so once you've declared your table or pointed it at an existing table, you can simply use the SQL data control language grant statements to grant permissions. So for example, you can grant permissions to a whole group like engineers. You can grant permissions on individual columns if you want, to another group, and so on. Now, the permissions aren't just limited to tables and columns. The Unity catalog also understands SQL views, and this allows you to create views that aggregate the data in complex ways and to give someone access to just a specific subset of the data. So for example, let's say that we had these IoT events we collected here, and for some users in our company, we only wanted them to see aggregate data by date and country instead of seeing the individual events. We can just create a view that aggregates that and grant select on that view. And the Unity catalog will make sure that these users can only see the aggregated data. So you can have arbitrary logic in there. You can also check the user's identity when deciding what data to show to them. And so you can implement complex policies that way if you like that model. Now, tables and views get you pretty far, but when you have to manage governance for very large data sets, in very large enterprises, you often also want a way to factor out the policies so that it's much easier to set a policy on a lot of data together. And so for that purpose, we're actually supporting attribute-based access control in the Unity catalog as well. This allows you to create an attribute, which is basically a tag that you can then attach to a whole bunch of data items and manage all the controls for that attribute centrally through one rule, as opposed to having to, to create hundreds of different grants on individual data items. So in this example, I'm creating an attribute PII for PII data, and then I can take tables and add this attribute on specific columns into it. And then I can write a statement that grants select permissions on any table in this database for any column that is not PII to a specific group. So now I have a single statement that sets the permission on all the data with this tag. And for administrators or data stewards, it's very easy to go in and add the tag or remove it from individual items and not have to worry about managing lots of different permissions on the tables themselves. So it's a really powerful way to manage security permissions at scale. So this has all shown you how to do this through SQL, just to emphasize that this is a standard way to do things that's going to be immediately familiar to anyone who's administered a database before. If you want to do this visually, we also have a great user interface for the Unity catalog. And so the user interface allows you to manage the tags or the grants directly in the UI and see who has access to it. And it also takes advantage of the auditing features that are built in to Unity catalog to show you who is using each table and also what data sets are upstream of it and what data sets are derived from it. So it actually gives you this immediate view about which tables are actively being used, who can I talk to about this table, and so on. And it's also a collaborative user interface where you can start describing your table within your organization and start telling people what this data is about so that they can easily discover it and work with it. So we're very excited that the auditing capabilities also allow us to build this aspect of the catalog. Okay, so that's been a little bit about how to use it. Now, how does it actually work under the hood? How do we actually enforce this and really securely give people access to these high-level definitions of the data? So the way it works is, your users on Databricks are running computation on just a cluster or a SQL endpoint that they're submitting commands to, and then that cluster connects to the Unity catalog. And the Unity catalog is what actually has all the data source definitions and the credentials to get to them, such as IAM roles or credentials to connect to a database and so on. So before any data is accessed, the user code has to make a request to the catalog, and the catalog can enforce the permissions and also audit the request before it actually gives it access. When actually enforcing the access, we've also designed the Unity catalog so that it works securely across any type of computation that the user may want to do. So it can be enforced in SQL, but also Python, Scala, Java, and R. Any user code can be running in there with any libraries. We don't want to limit what kind of computation you can do in order to stream the data into it securely. And so we've designed the protocol between the user code and the Unity catalog to deliver the data securely and as efficiently as possible in all these situations. And basically the way it works is the user code never gets the raw data that they're not supposed to have access to or the raw credentials, such as an IAM role. They always get either filtered data that the catalog service will filter for you, or they'll get these short-lived tokens that allow them fast direct access to specific underlying data files. So just as an example, let's say you have user code that connects to the catalog and it's asking to select data from a table called events. And imagine that this user is actually allowed to read the whole table. They have permission to do that. In this case, the Unity catalog will check the permissions, audit the access, and then it will actually give the user code a temporary S3 token that allows it to read just those files within the events table. So this transfer, the reading of this data will be extremely fast when the user has full permissions on it. It's basically, as fast as if we weren't running the catalog in front of it as well, but it's much more secure than giving the user code an IAM role because it will now always be in sync with the table definition. And if we ever change permissions or we change the table definition, you don't have to hunt up all these IAM roles and figure out, what files in a directory structure they had access to. And of course, if the user was only allowed to select a subset of it, we would just filter the data first before giving it to this user. Now, that was all about accessing tables, but we're also really excited about the support for managing non-table access in a centralized way. So just as an example, this is how our interface looks for managing machine learning models. You can have models from your MLflow model registry be visible in the Unity catalog, and then you can grant permissions on them, for example, to individual groups. And then the other thing you can do is you can also add attributes on models, and you can grant permissions, say on all models having a specific attribute to a specific group. So you can actually start governing machine learning models, files, and of course tables and views through the same attribute system, which is something that's very difficult to do today, and will give you a super straightforward way to actually manage all the data and all the derived assets in your organization. Finally, we've designed the Unity catalog to be open, to integrate very widely with the ecosystem of both existing storage, existing data catalogs, and also potential clients that can connect to it. And we're doing this in a few different ways. So first of all, the Unity catalog can easily connect to existing catalogs you have, such as an Apache Hive Metastore, and add fine-grained permissions in front of those, so you don't have to move your data. And it can also connect, of course, to storage systems where you have tables, such as Amazon S3, Azure ADLS, Google Cloud Storage, and so on. And you can also connect the Unity catalog with partner products such as Immuta and Privacera that allow you to centrally govern data and create sophisticated request workflows and maybe manage data that's living in other systems as well, not just in Databricks. So we're working with these partners to make that straightforward. Now, at the same time, if you want to access data in the Unity catalog from outside Databricks, for example, from your favorite data warehouse or something like that, that's also possible through the Delta sharing project that we introduced, or just through standard JDBC and ODBC. So the data is not locked into the platform. You can efficiently read it from other places, and this will also enforce the permissions that you set in the Unity catalog for those users. And finally, we worked really hard to make the interface for setting permissions standard. We think it's untenable to have lots of different proprietary interfaces for managing permissions in every cloud and in every other system where you work with data. And so we chose the ANSI SQL data control language with grants and user groups and so on to make this something standard where a lot of administration tools can support it, and any user who's managed a SQL database before can begin administering a subset of your catalog if you'd like them to. So that's a summary of the Unity catalog. Unity catalog brings fine-grained centralized governance to Lakehouse and data lake and machine learning through a very simple standard interface, which is ANSI SQL. And we think this is going to be essential to fully realize the potential of the Lakehouse model. Thus far, the governance model for data lakes has simply been more complicated than it needs to be, and there's no reason for it to stay that way. So with Unity catalog, you'll be able to manage all this data, as if it was a SQL database. You'll have fine-grained permissions, and you'll be able to access it from a wide range of systems, and it will still be highly efficient, low cost, highly reliable, and it'll have all the advantages that Lakehouse and data lake systems have today. So you'll be able to work with data across clouds, across storage systems through this unified interface. We'd love to have you try out the Unity catalog, and we're inviting users to join our waitlist at databricks.com/unity to try out the catalog when it's ready. Thanks, and back to you, Ali.
Thank you, Matej. Now with strong data governance in place, let's turn our attention to how we can actually put it to use. Last year, we announced Databricks SQL capability on Databricks to allow data analysts to directly query the most recent and most complete data in the Lakehouse through tools like Tableau and Power BI, rather than waiting for outdated excerpts be made available in downstream data warehouses. Since we announced Databricks SQL, we've been focused on several aspects of this experience. First, we've been hard at work to make it super fast to query the data and also reduce the latency of it. Second, we've continued to scale up the concurrency to enable very large data analyst organizations to have a delightful experience. Third, Databricks SQL now provides even better visibility into workloads, usage, and troubleshooting. I'm excited to have you see all the progress that we've made, and I'd like to welcome Reynolds Shin, Chief Architect at Databricks, to walk you through it.
Thank you, Ali. Good morning, everybody. At the last Data and AI Summit, we announced a new product targeting SQL and BI use cases called Databricks SQL. The approach we have taken is very different from traditional data warehouses. So rather than taking a closed approach to manage data, Databricks SQL relies on the lakehouse architecture to store and govern data in an open way. This way, it shares the same underlying storage and governance with the rest of the use cases, such as data engineering, data science, and machine learning. In this talk, I want to give you some update on the progress we have made since then. Our vision for Databricks SQL is very simple. We want to provide the most performant, the simplest, and the most powerful SQL platform. And we'll do this in an open way, and open doesn't have to come at a cost. SQL is a very important part of the lakehouse, and there are a lot of capabilities that go into offering a great BI and SQL experience. We'll make some major announcements here. For example, in the earlier talk today, you have heard that Matei announced a Unity catalog to provide cataloging and governance for your data. At the last Data and AI Summit, we announced a combination of SQL endpoints and the Photon vectorized engine to bring state-of-the-art performance to Lakehouse and a better interface based on our Redash acquisition for SQL users. However, as all of you know, we don't get to realize a long-term vision by just a sequence of announcements. We get there by working closely with you, our customers, to improve the system over and over again. In this talk, I want to share with you some of the exciting improvements we made. Given Michael has already talked to you about the storage layer and Matei on the catalog and governance, I'll start at the next layer above to talk about the work we have done to improve real-world performance, followed by some of the UI work. And these improvements are part of the Photon engine. For those of you that attended my talk at the last Data and AI Summit, you might remember a chart I showed that compares Databricks SQL performance with the other cloud data warehouses using TPC-DS 30 terabyte scale benchmark. Since TPC-DS is an industry standard benchmark defined by data warehousing vendors, we're really proud that we could beat them in their own game. However, some of you also pointed out that since Databricks started as a massively parallel data processing engine, it's not surprising that Databricks SQL to do really well in benchmark that process terabytes. As a matter of fact, 30 terabytes of data. Our Achilles heel is in the other scenarios. So we heard you. And for the past 6 months, as we were previewing Databricks SQL with our customers, we worked with a lot of them on their real-world workloads and focus on optimizing those. And in the performance section of the talk, I want to cover a few real-world scenarios. This includes small concurrent queries, mix of small and large queries, a lot of small files with poorly laid out data, and the last mile delivery of data to the clients. The top question in all of your minds have been, yes, Databricks is really great for crunching a lot of data, but how well would us do with a lot of users and small data sets? So to measure that, we used the TPC-DS benchmark again, but this time using only 10 gigabyte scale factor. So going down from 30 terabyte to just 10 gigabyte. It's a much smaller one, and 32 concurrent streams to simulate a lot of users. We first measured actually one of the best cloud data warehouses, and we saw that it could process around 11,000 queries per hour in this scenario. Back in July last year, when we measured Databricks SQL, it was able to handle only 5,000 queries per hour using a similarly priced system as the cloud data warehouse. So we then put together a SWAT team to look at the problem, analyzing where the bottlenecks were and removing them one by one. There's really no single brilliant algorithm here, just a lot of hard work, shaving things off one by one. In November last year, we made quite a bit of progress and improved the system by 40%. Now it could process actually 7,000 queries per hour, and we continued. And I'm super excited to actually show you that after over 100 different micro optimizations, we measured again in May, and we found that we have tripled the number of queries that can be processed per hour in just less than a year. And Databricks SQL now outperforms the cloud data warehouse, not only for large queries, but for small queries with a lot of users. Of course, we're not done here. We have identified a lot of other changes to improve concurrency and short query processing even more, and we'll share with you in the future conferences. But real-world workloads are not just small queries or just large queries. They instead include a mix of small and large queries. And we have seen a lot of those in the past few months of Databricks SQL preview. and we'll work very closely to add specific optimizations for them. Previously, Databricks SQL had a single queue for all queries. And that is when the system's saturated and as new queries keep arriving, they get queued up and will be executed when some capacity of the system freed up. And this would actually cause a problem with large queries blocking small queries. And consider the example I'm showing you on the screen here. At 5 o'clock, we have a very large query that's using all the capacity of the system. Then 5 minutes later, 2 small queries came in. Perhaps the CEO is trying to open a dashboard with those 2 queries. And those 2 queries typically just run for a couple seconds because they're very, very quick and use very little resource. However, because if a large query have consumed all of the resources in the system, those queries would have to wait until 20 minutes later. And this means the CEO actually waited more than 15 minutes for the 2 queries as opposed to take just 10 seconds to complete. 15 minutes rather than 10. So we have received a lot of feedback from customers, and we designed actually a completely new approach to solving this problem. And the insight between our new approach is that most end users really care about the latency or how fast you can run the short queries, and not much about the latency of long-running queries or large queries. In this new approach, instead of having a single queue, we will now have 2 different queues, and a standard queue and an express queue. Queries that come into the system are analyzed first to determine if they are large or small. If they are large, they go into the standard queue, and if they're small, they run into the express queue. So in the same example, at 5:05, when 2 small queries come in, the system will process them immediately without the large query blocking them. This way, the 2 short queries are processed just within 10 seconds, and the large queries runtime had barely had any impact. And this really simple dual queue approach makes the system feel a lot snappier to all users, regardless whether they're running smaller queries or larger queries. The third scenario I mentioned earlier is too many small files, and this can happen for a lot of reasons. For example, a streaming job without compaction could accidentally create a lot of small files without the users even noticing. And to read 10,000 1 megabyte files, the most of the time in the system would actually be spent just opening and closing those connections rather than reading the content of the files, which is what we want the system to do. And this would significantly slow down the system as opposed to reading, for example, just 100 megabyte files. And this is often called out as the main Achilles heel of an open system because the system doesn't have complete control over the underlying files. To alleviate this problem, we designed a new scan operation called async and parallel I/O that can automatically read the next blocks of data while the current block is being processed. And this actually increases the performance of the small files dramatically by 12 times for 1 megabyte files as we've measured here. In addition, the same optimization doesn't just help small files. It also helps when the files are large, but they're just residing code in the object stores and not cached locally in the system. So really bringing much better I/O performance across the board. The last performance feature I want to talk to you about is about the last mile or the boundary, how the system delivers results to clients. This is very important for anybody trying to get a large amount of data out of the system, like a BI extract scenario. And previously, just like pretty much any other data warehouse, a client would fetch data in a single thread going through a single node, typically like a coordinator node. Not an issue at all if the client is just trying to fetch a couple megabytes, but can be very, very slow if the client is trying to fetch hundreds of megabytes or even gigabytes of data sometimes. So we've reworked this with a really cool architectural change that for large results, the underlying cluster now write in parallel across all the compute resources to cloud storage like GCS, Azure Blob Store, or S3. And then the server sends a list of files using precise URLs back to the client. The client can then download all the data in parallel from the object stores. So this is to say, all of the metadata are sent in serial order because they are small, but all the data that are large can be parallelized both in the writing phase and the reading phase of the client. And we call this Cloud Fetch. In the real-world customer scenario we have tested, we observe actually up to 10 times performance improvements for end-to-end query execution time. So this includes the time for a BI client to actually fetch all of the data. And it's quite incredible. What I've shown you just now, a list of very different scenarios that I worked on for real-world performance beyond just one single industry benchmark, TPCDS. The goal is to provide you the best price performance for SQL workloads while retaining all of the benefits of the open platform. The key enabler for this is the Photon engine, and we announced private preview of it last year. I'm happy to announce that Photon will enter public preview phase in the next few weeks. But all of you know that performance, while it's extremely critical, isn't everything. When we're creating Databricks SQL, wanting to build not only a really performant product, but we also want to create a very simple product, simple as in easy to use. Next, I want to show you some of the progress we make in simplicity, starting with admin experience, followed by analyst experience. Admin's first impression in Databricks SQL is usually how simple the form is for creating a SQL endpoint. This is because with SQL, the underlying system has now more opportunities to understand the workloads, as opposed to generic Spark workloads. It might be a little bit difficult for the underlying system to understand. Databricks SQL takes full advantage of that. It will automatically tune the underlying resources for SQL. For example, it automatically picks the best VM types, so customers don't have to worry about what type of VMs run best for SQL queries. It automatically tunes the configs, so the cluster's auto-tuned. It automatically scales the system as load comes in for more concurrency, and it's really, really easy to get started. It's also really easy to monitor. We provide a simple and beautiful UI for admins to understand their workloads. They can quickly look at sort of the monitoring tab to understand how workload vary across time, and they can drill into specific time periods if needed. Now, of course, admins can also look at the set of queries that run against the system in the query history page. Admins or users themselves can also leverage the query detail page to understand the performance characteristics of those queries, like why are they slow. This is a much better, simpler to use, and beautiful UI for SQL queries than what the old Spark UI provides. In addition to the administrative simplicity, we've also dramatically improved the SQL developer and analyst experience. First of all, we work very closely with a large number of software vendors to make sure you can easily use your tools of choice on the Databricks SQL product. We already told you a lot in the past about Tableau and Power BI, but the ecosystem is so much larger than that. We made it easier to connect, easier to get data in, easier to authenticate using single sign-on, and of course, with all the concurrency and short query performance improvements, we make sure that the direct and live query performance is great. But we're also focused on providing a first-class SQL development experience within Databricks SQL. We've talked to hundreds of analysts that use various kinds of SQL editors like SQL Workbench every day and work with them to provide a dream set of capabilities for SQL development. We've added a long list of features that I won't be able to go through all of them, but some of them are highlighted on the screen here, and this includes the query tabs, so you can work on multiple queries at the same time, autosave, so you never have to worry about losing your drafts, integrated command history, so you can easily look at what you have run in the past, and much better autocomplete that understands subqueries and query aliases. We've also added debugging capabilities in the editor, so now you can see query progress, error highlighting, execution time breakdown without ever changing the environment. And last but not least, we stayed true to Databricks' unified approach for collaboration with a lot of rich set of features for collaboration here. I personally found it very difficult to understand how well a product works just with screenshots. So I want to invite John Efiolu, our product manager for Databricks SQL, onto the stage to show you a quick demo of what I've talked to you about so far.
Thanks, Reno. Let's get into it. Imagine that you and I are data analysts at a chocolate bar company, and we're tasked with figuring out which regions to source our cocoa beans from to get the best value and ratings for our chocolates. Let's start by taking a look at the chocolate database here, which contains all the data for this project. And the data browser really shows us the details here about the individual tables as well as their columns. And the reviews table seems to be the one we need. So let's get a quick preview to confirm that it is. This looks good, but I do want to keep this preview readily accessible for later. So I'm going to switch to the Previews tab. And the new tabs in the SQL editor honestly makes multitasking super easy without losing any context. So let's start working on that query now. And as I type, honestly, autocomplete saves me so much time here, as well as additional clicks. It's gotten smarter too, and now works with things like more complicated queries that include subqueries or aliases that are deeply nested. And Well, now that we made the query look a bit prettier too, let's go ahead and execute. And you'll notice the progress indicator tells us the stage of the execution, so you always know what's going on as well. And if you ever need to go back to a previous query or its results, you can just use the integrated query history for this. You can go back in time to any of these queries, view their results, and if you want to, leverage them for your analysis or just go back. And coupled with the new auto save and drafts features, you will never have to worry about losing work, even if you just close your browser windows here. Now, to switch gears a bit, let's imagine that we're instead administrators managing SQL endpoints. Creating one is simple. Pick a name, pick a t-shirt size, and just make sure the right folks have access. This is all synced to your identity provider automatically behind the scenes. And you're done. It'll scale based on your user and workload loads automatically. So you have that peace of mind. And for an existing endpoint, understanding usage is simple too. You can look at workload trends and peak usage periods right from the monitoring UI. In this case, it looks like May 11th through 14th has been a busy week for that endpoint. The query history gives us a way to drill down even further here. You can view activity from BI tools, the built-in SQL editor we just looked at, or any other client. You can filter this by a specific endpoint, a specific set of users, a date and time period, as well as the status of a query. And for an individual query, getting insights on where the time was spent and any other execution details is a breeze to with that new execution summary pane. And this is huge in terms of time savings for administrators trying to do auditing and troubleshooting. And that concludes our quick walkthrough. We're very excited about the progress so far, and even more so about what's to come. Back to you, Reno.
Thanks, John. I hope this talk and demo give you a good understanding of the progress we've made. We have achieved best-in-class performance for a lot of different real-world scenarios, from small queries to large queries to a mixture of large and small queries. We made it dramatically easier to use your favorite BI tools and provide you a first-class SQL development experience directly on top of the Lakehouse platform. We're not sitting still. As you're watching this talk, our team are working nonstop on a whole new set of capabilities that will provide even more speedups, make the platform even simpler, and even more pleasant to use. At this conference, there are a number of talks about various different aspects of Databricks SQL from both Databricks and our customers, and I've shown some of you on the screen. I would encourage you to check them out. Last but not least, starting June, we'll public preview Databricks SQL as well as the Photon engine. You can go to databricks.com/try to get started. Thank you very much. Enjoy the rest of the conference. Passing back to you, Ali.
Thanks, Reynold, and thank you to everyone who presented today. I hope you're all as excited as we are about the work that's being done to advance the Lakehouse paradigm. To summarize, Delta sharing is the world's first open protocol for data sharing in a secure way, enabling collaboration. It has great ecosystem support already, and we believe it will redefine data sharing in the same way that the Lakehouse is redefining how people use data lakes and data warehouses together. Delta Live Tables is going to make the experience of building reliable data pipelines on Delta Lake extremely easy by taking a lot of the manual legwork out of the process. And with the Unity catalog, you'll be able to easily govern all of your Lakehouse data across any cloud. And as Reynold just mentioned, Photon is rapidly making the Lakehouse the ideal home for all traditional analytic workloads. Microsoft has seen the potential of data and AI for a long time, so please join me in a chat with Rohan Kumar, CVP of Azure Data at Microsoft, as we discuss the trends happening in the industry.
I'm super excited to have Rohan Kumar, Corporate Vice President of Azure Data at Microsoft, with us again at Data and AI Summit. Welcome, Rohan.
Thank you, Ali. It's great to join you for the Data and AI Summit. This is an event I look forward to every year.
So you've been with since the beginning of the partnership with us on Azure Databricks since 2017. Tell us a little bit about your observations.
Yes, it's been an amazing partnership with you and the rest of the team, Ali, and it's been a very good experience co-engineering Azure Databricks. As you mentioned, Microsoft and Databricks have a unique, first-party service relationship. This partnership enables distinct benefits to our customers, not offered in any other cloud. Over the years, we've baked in benefits such as our native security and identity offerings, enabling customers to safeguard their most sensitive data and enhance compliance, and our ability to provide unified mission-critical support as a simplified engagement model. The first-party integration and our unique strategic alliance save customers a lot of time and effort and significantly accelerates time to value.
Absolutely. We've really enjoyed the first-party partnership. And last September, together, we announced exclusive announcement of Photon at Ignite. And I'm curious, now some time has passed and we've worked with customers. What are you hearing about that?
Customers are really excited about Photon, Ali. I mean, early learning with Photon has demonstrated that can be up to 20 times faster than open source Spark. Also, Photon exclusive preview on Azure is a great example of our partnership. Customers love the fact that Photon is available first on Azure Databricks. And within the first month of launching the preview, we had nearly 200 registrations to get access to the preview, including innovation-driven organizations like Grab and CarMax. Grab, for those who are unaware, is the largest online to offline multi-service platform in Southeast Asia. Its various apps have been downloaded more than 200 million times, and it generates over 6 billion transactions for transport, food, and grocery delivery and digital payment purposes. The Grab team is excited to accelerate analytics using Azure Databricks and Photon to help identify opportunities for millions of people across Southeast Asia.
Let's talk about our joint customers. A lot of joint customers that have been using Azure Databricks with other Azure data services and other Azure services that are provided. Can you tell us a little bit about what they're doing and some of the interesting use cases?
Absolutely. ABN AMRO Bank comes to mind right away. ABN AMRO is one of the Netherlands' largest full-service banks. They've been on a journey to modernize systems that house customer, marketing, and financial reporting data. A cloud-based integrated data platform enables them to build an enterprise-grade data and analytics platform solution. With Azure Databricks for data curation and pre-processing, Synapse Analytics as a secure data warehouse, and Power BI as their reporting and dashboarding tool, the solution lets ABN AMRO reap the benefits of best-in-class capabilities. The solution is already increasing their agility so that ABN AMRO can bring new services and use cases to market much more quickly with a data-driven approach. The new platform provides improved insights, giving the company an end-to-end view of the customer, marketing, and financial data to empower the users to make faster and more accurate business decisions. And with discount provisions like reserve capacity, ABN AMRO is also able to dramatically reduce TCO. Another customer that comes to mind is Walgreens Boots Alliance. They're a global leader in retail and wholesale pharmacy. In the US alone, Walgreens operates more than 9,000 stores and processes 1 billion prescriptions a year. With Azure Databricks and Delta Lake, Walgreens is building an open data lake to enable real-time data engineering pipelines to process millions of transactions in seconds to improve their pharmacy customer experience and optimize operations. And then Walgreens combines this with AutoML and MLOps capabilities in Azure Machine Learning to expand their data science teams and create thousands of models to enrich loyalty programs and reduce customer churn.
Those are some amazing examples. At Databricks, one of the trends we are seeing is that customers are using data lakes and AI in a combined approach to build open, simple, collaborative solutions. We call it the lakehouse paradigm. What are the trends you are seeing with our joint customers?
To answer your question, let me break it into two parts. First, open architectures. We're seeing customers choose to run their data and AI workloads using open standards. For example, Delta Lake, which integrates across products on Azure. At Microsoft, we also continue to support the community by actively contributing. A recent example is the hyperspace support for Delta Lake, which helps accelerate query creation with indexes. Similarly, on the ML side, we are active contributors to MLflow and have worked to integrate it seamlessly with Azure Machine Learning. Customers love this active collaboration with the OSS community as it helps them accelerate time to value. Now, the second aspect, collaboration. A great example is Databricks. The joint engineering effort with Databricks ensures seamless integration of Azure Databricks with services such as Azure Data Factory, Azure Data Lake Storage, Azure Synapse, and Power BI to deliver consistently integrated experience for our customers. The highly optimized Azure Synapse connector, for example, is the most popular service connected across all of Databricks. Over 1,500 customers such as Marks & Spencer, Rockwell Automation have used Azure Databricks and Azure Synapse together to modernize their analytics platform in the cloud and gain high performance and scalability. For ad hoc reporting and root cause analysis type scenarios, the Power BI connected to Azure Databricks makes it easier and more performant to deliver great BI visualizations and reports through the same Power BI service. These are just some quick examples of the open and collaborative approach we've taken as a part of the analytics and AI offerings. The combination of these services operating seamlessly together reinforces why Azure is the preferred destination for running mission-critical analytics and AI workloads.
So Rohan, another aspect that we're seeing more and more is openness and open standards and open source around governance and security for our joint customers. Are you seeing those trends, and what are you seeing around that?
Sure, Ali. In these times when there is increased scrutiny around how data is consumed, ensuring the right use of data is of utmost importance for our customers. To me, right use means meeting corporate security, privacy, and compliance standards, as well as ensuring compliance with regulatory requirements. Satya announced Azure Purview in December last year. Purview is a unified data governance service that helps customers maximize their business value of their data. Purview offers customers a hub where users, from data engineers and data scientists to business and technical data analysts, can publish, find, understand data assets across the enterprise. Purview also follows the same principles of openness and collaboration as we discussed earlier. Purview is designed to integrate seamlessly with Apache Atlas, which is a common open source solution for some of the data governance needs. This allows customers to build on their existing investments. Purview integrates with data systems in Azure, on-premises, and other clouds, allowing our customers to greatly accelerate their data governance journey. At Microsoft, we believe that data sharing should be an open and not lock customers into using a specific data store or analytics platform. Our investment in Azure Data Share reflects that point of view, and we see Delta Share as being aligned with that vision. Going forward, we see real potential for synergy between Azure Data Share, Azure Purview, and Delta Sharing.
Yeah, we're super excited about that partnership and the collaboration between those services. On that note, thank you so much, Rohan, for joining us today. It's been an absolute pleasure working with your team and collaborating, and we're looking forward to deepening the partnership for many years to come. Any final comments?
Thank you, Ali, to you and the rest of the Databricks team for being such amazing partners. And thanks to everyone for listening in. Hope you all have a great rest of the summit. Please stay safe.
Thank you.
Awesome. We've covered a lot of ground so far, but this is just the start of Data and AI Summit. Many more exciting innovations and perspectives to share over the next couple of days. Thank you again to all the presenters so far, and to all of you for tuning in. Now it's my pleasure to introduce our first guest keynote. As I talked about up front, the spirit of this conference is rooted in a shared mission to solve the world's toughest problems. We've invited Malala Yousafzai to this year's summit because she brings a unique and very personal perspective to some of the systemic issues that we face as a society. People like Malala are the ones who inspire us to consider the role that technology, data, and AI can play in solving the world's toughest challenges. Malala is a Pakistani activist for female education, and she's the youngest Nobel Prize laureate. Through her foundation, Malala Fund, her advocacy has grown into an international movement. Please join me in welcoming Malala to the Data and AI Summit.
Thank you so much, Ali, for that kind introduction, and thank you so much to Databricks for giving me the opportunity to speak today. And I have read that you have over 100,000 people who will be hearing this summit this year from around the world. So I'd like to say hello to all of you, and to be in such a diverse community, I would like to say Assalamu alaikum, marhaba, hola. I don't know, I think I'm forgetting all the hellos in all the languages, but I'm just so glad to be in the company of you all. I am just so grateful that I have the opportunity that I'm able to share my story. And some of you might have heard it and some of you may not have heard it. But basically, I come from the north of Pakistan, and I was born in this valley, which was known to be the Switzerland of the East. And Queen Elizabeth also visited it, and she has praised its beauty. And it was known as a place of tourism, but that changed when I was just 11 years old. And that was the time around 10 years ago that terrorism started. And it started in the form of these extremist people in our society who started imposing strict laws, their so-called Islamic laws, in which they basically were against the freedom of people. They wanted people to behave in their way and according to their code of conduct. They especially targeted women, including the fact that they were not allowing women to go to markets. And then it changed for me personally and completely when they announced a ban on girls' education. And I was just 11 years old when I realized that, that my right to school was all of a sudden taken away from me. And I still remember waking up that morning in 2009, and I realized that I could not go to school anymore. And that day I cried. I was talking to my father what it meant for me when I would not be in school. And he was a passionate teacher. He was running that school for so many years. He had both girls and boys sitting in that school learning and getting their education. And he also knew that this meant a future for so many girls. And we had already seen in our society that when girls are not in school, they are more vulnerable to early child marriages. Their parents, their brothers prohibit them from going outside of their houses. They often do not have a choice in their life decisions, and a lot of them have children when these girls themselves are children. So just imagining all of that in that moment, for me, it was a point where I realized that education was more than just learning and reading. It was about the emancipation of women. It was about the freedom of women. And I was worried about my identity. I was worried about who I was and what it meant to me if I were not in school and if I did not have access to education. Because many girls many girls go nameless. Many girls just disappear from society. Many girls do not get the opportunity to follow their dreams because they do not have access to education. So school was a place of emancipation for me and many girls. And that's why I decided to start my campaign and start speaking out to local media channels, to national media channels and international media channels. And I initially was just telling my story, the story of what was happening in my valley, highlighting that more than 400 schools were destroyed, highlighting the fact that women's freedom was taken away, that women were not even allowed to go shopping, and that girls' education was completely banned. And I was not aware whether my story would be heard or not. I was just trying to do my bit to ensure that at least I raise my voice for truth and I raise my voice for what is right. Because I did realize that a lot of people were silent, either because they were scared that the terrorists would target them, or because they were just they just didn't have the courage or didn't have the opportunity to be bold and to speak out what was actually happening, to speak the truth. So I knew that if nobody spoke out, nothing will change. So I have this strong belief since then that if you want to see change in your community, you have to speak out for it, because things will remain as they are for as long as we keep quiet about them. And since then, my father and I have been doing activism for girls' education. And a lot of you might have heard the rest of the story, that I was attacked, and because of my medical treatment, I was moved to the UK. And since then, I have had this incredible opportunity to campaign for girls' education globally, because it was not just girls in Swat Valley in that one specific year that could not go to school. There are 130 million girls around the world who do not have access to education. And education is not just about the emancipation and empowerment of individual girls and boys, but it's also about the transformation of society, making it a more making it a healthier, greener, a more peaceful place for everybody, making it more inclusive, and ensuring that everybody from any background gets the opportunity to follow their dreams and to live their life according to their choice. So I look forward to talking more about all of this in the conversation. But what I would reinforce in my introductory remarks is that that you all are in such incredible positions. You have had the best quality education that one can ever imagine, whether it was your formal education or whether it was the informal education that you have received from your mentors, from your friends, from your colleagues. You have this incredible opportunity to make this world a better place through your ideas, through your creativity. So I will say that, keep spreading this knowledge and pass it on to others, because, when we multiply these amazing ideas and this knowledge that we have, it makes this world better, more inclusive for everybody. So education and knowledge are sources of empowerment. So do take advantage of these opportunities. I look forward to the Q&A with Ali now. Thank you.
Mala, thank you so much for joining us at Data and AI Summit. Your story is so inspiring to millions of people around the world. So to start, I'd love to just learn more about what inspires you. What are some of your childhood heroes? What are your favorite books, authors, or other leaders that you admire?
Wow, that's a lot to mention in that. For me, I really valued the people around me, my dad, my brothers and my two brothers and my school friends. I learned so much from them. And I was hugely influenced by Indian TV dramas and Bollywood movies. So I have watched that for my whole life. And I am more of a fantasy person. So I used to imagine myself, on the TV screen a lot. I was a big fan of Cartoon Network. So I watched literally each and every cartoon, from Tom and Jerry to Courage the Cowardly Dog to Pink Panther. I don't think I have left any cartoon. And I think probably my favorite one was Powerpuff Girls and Courage, for sure. Other than that, I had watched quite a few movies back then in Pakistan. I think one of that was the Titanic, which everybody has seen. And I did not read that many books in Pakistan outside my school curriculum, because children are usually limited to their school textbooks. And, I, at age, I think 10 or 11, started picking up books outside my school curriculum. And one of the first books that I read was A Brief History of Time and The Alchemist. And I loved physics back then. And I was always curious about, just the world around us and how things work on such a, minute, microscopic level, to then how it works, in the universe that we are living in. I enjoyed that. And I've always been a curious person, trying to know as much as I can.
The internet today hopefully is changing things for a lot of young kids in Pakistan and other places. They'll maybe hopefully have more access to books. Do you think that's a big change, and do you see hope around that? How technology can help them actually maybe read more and get access to things that they didn't have access to before?
Technology has brought in so many opportunities for us to create a world that is more inclusive. And I think we should look at the tools of technology and use it for the betterment of society. So I think it's up to us how we use it. The tools are there, the technology is there. And I think in exploiting and in using technology, we do need diverse voices. We do need more ideas, at the table. And I think when we have more voices at the table, we will get better ideas in how to make sure that technology is helping all of us, not just some of us. So, and even in this time of pandemic, especially, all of us switched to online learning. My last semester of university was through my laptop screen. That was all I saw. I was sitting in my bedroom, taking my classes through my laptop, taking my exams on my laptop. Everything was just on a screen. And so I think it has allowed us to imagine, education in a new way, because, we have always been very, very strict about the concept of education and think in more the traditional sense. But I think it's time that we take a step ahead and have a bit of faith in how we can use technology in providing access to education to people who are living in remote areas, or girls who might find it difficult to travel to school. Walk for them may not be safe. They might have other difficulties in reaching to a classroom. So how can we use the technology to ensure that they continue their education wherever they are?
That makes a lot of sense. Many people would say that you're living proof that anything is possible. A young girl living in the most challenging circumstances and what you had to go through, and then grow up to be a Nobel Laureate, graduate from Oxford, and you inspired a whole global movement. you must have an unwavering willpower and optimism about you. Where did that come from? And what advice do you give to other people so that they can stay optimistic?
For me, it's really important to stay committed to the cause of girls' education. I have been one of those girls who could not go to school at age 11, and I know how crucial it was for me to be in school. It was not just about learning, reading, and writing. It was about my safety. It was about my protection. It was about my future and me being able to make choices on my own by myself in my future. Because when many girls are not educated, they are not able to make decisions for themselves. They're not able to make informed decisions for themselves, and they do not even know about their rights, their body rights, their constitutional rights, that they should not be getting married before age 18. All of these things, I think education is truly empowering. But also, I have met girls globally around the world. I have met girls in Nigeria, in Iraq, in Lebanon. I have met Syrian refugee girls, and I have met girls in the UK and in the US. And many of them come from very challenging backgrounds. They have family difficulties, they have financial difficulties, they have become refugees, they have become displaced from their homes, they have seen terrorism, they have seen extremism, all of those things. But despite that, these girls never give up. I remember one girl in a refugee camp in Iraq, and she was a Yazidi girl whose family had to flee their village because of ISIS. But also, at age 14, this girl was, pushed by her family to get married. And she was telling her story of how she decided to take off her high heels, and she escaped and ran away on her wedding day, because she knew that her future should not be getting married at age 14, that she should be in school. Every girl knows that she should be in school at this age, and that she should be learning, she should be in a classroom. So these, when you hear these stories of these amazing, courageous young girls, it truly inspires you. I feel like, there's still a lot more to do, and it's for the future of these girls that we have to keep on fighting.
So it's the cause that kind of drove you and gave you sort of hope to be optimistic and continue the sort of struggle.
It's the cause, but it's also like it includes lives of people. And I know how many girls lost their dreams because they were not allowed to go to school. I remember my friend, when we were in grade 5, she stopped attending our school. Everybody was worried where she had gone. And then, we were the same age, and at age 14, she called me on phone. And I was, really worried about her. I was like, what had happened? Why did you stop coming to school? And she told me that she was already married and she had a kid when she herself was a child. So, these are just unimaginable stories, but people go through it, and girls are still going through it till this day. There are 130 million girls who do not have access to education. Even the girls who do enroll into school are not able to complete their educations. They do not reach to their secondary education because, when they reach their puberty age, they face a lot more challenges. They face family pressure. There are not enough schools in their areas, or they are forced into early child marriages.
What's the best way to get people who, think that the right thing, for my girl that's 13 years old is to get married? How do we help them understand that you're not giving, this is not right. Your daughter could be so much more. She could, there's a whole world. What's the best way to, get through to them?
So, this is the cause that Malala Fund has been fighting for, and our goal is to ensure that all girls can go to school. I wish there was just one solution to that, but unfortunately, there are many factors we have to fight against. And I think, the one which you mentioned is convincing people, is having this conversation, and which is addressing social norms. And Malala Fund has been investing in local education advocates who are doing campaigning on local community level, who are encouraging the local leaders, including religious leaders, to talk about the importance of education. And we have seen that in Afghanistan, in Pakistan, and other areas as well. But then at the same time, it's also the availability and the supply side of this issue, which is like, are government providing enough schools? Are they providing quality schools? Are they addressing the local issues? Like in some areas, the issue is not as much the school, but are parents feeling safe, for their children in school? Some parents prefer to have female teachers in their schools, and they feel more confident to send their daughters to school that way. So are we providing, training to female teachers? Are we ensuring that there are enough female teachers? Because that way you could, address the issue, which is one of like our focus is in Afghanistan. We are working on training female teachers. So financing for education is important. There's a billions of dollars gap in it, and world leaders need to ensure that they invest the money that they need to sooner, as soon as they can. And especially now that this pandemic is happening, there is a risk of 20 million more girls dropping out of school, because in this period, like it's already been a year, when a girl is sitting in the house, she's supposed to do all the house chores, she's supposed to be taking care of the family, and oftentimes if she's a burden on the family, she's married off, or she's told to become the financial supporter of the family, to earn for the family, because their father's income or their male family members' income has been affected by the pandemic. So many of these girls may never return to school. So we are already talking about the gap that is developing, that from the fact that children have missed out on their education, that is months and months for many children in developing countries. So there is a risk that more girls may not be able to return to school, and we don't want to see the number increase. We want to see the number of girls out of school decrease. So this is the challenge ahead. But we need to do a lot, addressing social norms, financing for education, talking about the quality of education. Is it gender sensitive? Is it inclusive or not? Is it actually providing girls and children with the skills that they need to prepare for the future jobs? Like in many schools, they are still like not learning about technology, for instance. And like we already know that we are surrounded by technology, and we need to already equip ourselves with the knowledge that we are going to need for our future work, which, already a gap develops, but, you have to sort of work 10 times harder on this. But this has been like the focus of Malala Fund to work on these different factors.
Are there things that developed countries can do to help, bring technology to these developing countries and make sure that there is access to education and technology?
The answer is yes, because there is a lot that every country can do. Developed countries, the donor countries, can increase their support for education. They can give more support to the secondary education of girls. They can focus more on quality teachers training and on the curriculum and content of education. We need to be a bit more sensitive to what kind of education we are providing, so that it's not just increasing the number of teachers, but like, are these quality teachers? It's not just an increase in the number of schools, but are these quality schools? Are they actually providing the material of education that children need? So I think financing for education has to be increased, and in that the US, the UK, the G7, G20 countries need to acknowledge the role that they have. And it's, so they make commitments to a global partnership for education, GPE. They make commitments to Education Cannot Wait, which focuses on refugee children education. They can make direct bilateral partnerships as well with the developing countries. There are so many ways in which they can, make their commitments. But at the same time, I think, there are other ways like canceling debts or, special drawing rights. And there are so many other ways in which they can help and assist the developing countries, because, maybe that a developing country is in a position where the debt that they have to pay back is far more than their education spending in total. So there could be a lot of debt burden, financial burden, especially in this COVID time. But at the same time, I will say that in developing countries as well, we need to do a lot more work on how they spend the resources and the financial assistance that they receive, but also how they're using the resources within their own country towards education, towards health, towards the good causes where it should be spent. So we are working like nationally in Nigeria, in Pakistan, Brazil, and all these countries to push governments to invest more in education, to have 20% of their budgets dedicated to education. and and increase their GDP spending as well on education. So there are ways in which every country can play their part.
I do want to talk about the industry we're in, Databricks, in tech, especially in data and AI. There's a significant talent shortage, and especially there is a big gender imbalance. What can we do as individuals, as governments, and also companies like Databricks to address this?
First of all, I would like to say thank you to all the women here, because they're already breaking the glass ceiling or the iron bars in front of them. And I think for a lot of little girls in school, they need role models and they need inspirations. And the textbooks that they are seeing so far, the TV shows that they're seeing so far, in the news that they are hearing so far, is quite limited. And oftentimes when we talk about technology and maths and engineering and just this nerdiness, we would often think about men and boys, and I think that has to change. So and I am hopeful and I am optimistic that the entertainment content that we are seeing right now, and even the language and the tone that we are using right now, is already having a huge impact. We are more gender sensitive in the language that we use, and we are seeing more shows and more movies that are showing women in the main role, which is where they should have been already. But and I think for people who are already in key positions, I think they should not take their position of leadership for granted. They have this unique opportunity to make crucial decisions about making their organization an inclusive place for everybody. And it could be small steps like how you make an advertisement, or how you give a speech in your office, or how do you send off an email. I think all of these things can have a huge impact. And I think for that, a lot of us, all of us need that level of training in the diversity, inclusivity work, because we do have unconscious biases, and we might say things, we might do things that are sort of unintentional, and we do that. For me, I might be more biased sort of towards women. I would prefer to have women staff, or for a good reason. So I think we also sort of need to question ourselves and think about the society that we want to create, but also do not underestimate the role that we as individuals can play. And I always keep talking about the role that that we have in our everyday life. What are we doing when we are in an office? What are we doing when we are at home? How do we treat our siblings? How do we talk to our parents? How do we talk to our relatives and friends? Are we promoting and pushing a habit or an idea? Are we encouraging it? Are we discouraging it? How are we contributing to the sort of the norms and the taboos that we are creating in society? So I would just say, never underestimate the power that you actually have in your actions and in your words.
So in the beginning, I asked you, when you grew up, who were your role models? I think you are now a role model for many, many people. Over time, you've become incredibly important global figure and a leader for change. How do you think about that role and the impact that it has on others?
I don't know. I think for me, one of the most important thing is that that learn from everybody around you, and you do not just look for good qualities, also look at your own flaws and the flaws of others. And I think you can learn through that as well. I've had the opportunity to meet quite a few world leaders, and oftentimes you learn what not to say and what not to do from them. So there's always something there to learn. And for me, I really appreciate the women who have made changes, who have made history, who have become the first presidents and prime ministers, including the first vice president in the US, and who have become the first CEO of a company, who have, and there are many women which have already, who have done incredible job in history, who have been behind the technology that we have right now, who have played a crucial role in coding and in sciences, but their names are not known or their names are unheard because they have not been appreciated. And we are looking back at history and seeing how they played a role even in like in reaching space and all of these things, but they were sort of left behind, or as if sort of the man had to take the mission forward. As you know, like we need to appreciate each and every person who has played a role in the developments that we have seen, in the progress that we have seen, and we need to appreciate each other and we need to support each other. So I'm in awe of every person who is making this world a better place. I always get inspired by people who have incredible ideas.
Yeah, and everyone can do their part. It doesn't matter. I mean, for me, my role model was my mother. Anyone can do that. You can do it in small ways around you. Before I say goodbye, I want to ask you, what advice would you give to 10-year-old Malala if you were to go back in time and if you knew what you know now?
I personally, I get asked this question many times, and I always say that I just don't want to give that 10-year-old Malala any advice. Like, she was fine. She was strong and committed. She was living in a very difficult time because Talibanization had started. Schools were being bombed by the Taliban, and she was concerned about her education, and there would be, shelling, like, bomb shellings and firings, but she would still go to her school. And she had this strong faith that change was possible and that she was strong and she was brave, even though she was like small 10-year-old. But I think that belief for her was really important. So I would want her to continue to have that belief. And I even know now that, that with time we lose a bit of that optimism. Sometimes we, have these big dreams and we are like, maybe, okay, I need to sort of, be a bit more realistic. But even now, if I am a bit optimistic about something, I know that I might change when I'm like 30 or 40. But for now, if I do believe in it, like, let me believe in it. Let me believe that this can become a reality. It doesn't do any harm. It makes me stay committed to the mission. And for me, that goal and that mission is to see every girl in school receiving safe and quality education. It was the dream of that Malala who was 10 years old, and it's the dream of this 23-year-old Malala as well. And I hope that this continues to be her dream, and that we see this dream come true sooner.
I love that answer. Why should she change? I mean, she had amazing impact. Malala, thank you so much for taking time to join us at Data and AI Summit and for all the amazing work that you've done. Thank you.
Thank you so much, Ali. Thank you for your time.